It pays to be smart. Studies show that the most intelligent people hold more positions of power, make more money, get better jobs, live longer, and just seem to have better luck. But scientists are still trying to figure out exactly what constitutes intelligence. Is it your IQ that makes you smart, or is it your creativity? Or could it be your critical thinking abilities? Just what does it mean to be smart? I'm Laura Helmuth, Editor-in-Chief of Scientific American. I want to share with you some ideas on intelligence. In this series, we'll cover a wide range of topics, including how to identify and nurture giftedness in young children, what steps we adults can take to increase our own intelligence, and whether humanity as a whole is getting smarter. Join me on this exciting journey through the world of intelligence research and its practical applications for your own life. It may just be the smartest thing you've ever done. Identifying genius is a dicey venture. Consider, for example, a ranking of the top 10 geniuses found on listverse.com, one of many similar lists you can find online. From first to last place, here are the honorees: Johann Wolfgang von Goethe, Leonardo da Vinci, Emanuel Swedenborg, Gottfried Wilhelm Leibniz, John Stuart Mill, Blaise Pascal, Ludwig Wittgenstein, Bobby Fischer, Galileo Galilei, and Madame de Stael. What about Albert Einstein instead of Swedenborg? Some of the more recently deceased might also deserve this appellation. Stephen Hawking comes to mind. Another female genius or two should make the cut, such as Marie Curie or Toni Morrison. And if a chess champion like Fischer is deemed worthy, other geniuses outside the arts and sciences ought to deserve consideration. Napoleon Bonaparte as a military genius, Nelson Mandela as a political genius, or Jeff Bezos as an entrepreneurial genius, to name a few candidates. All these questions and their potential answers can make for some lively party conversations. But what they reveal is how little we understand about the origins of intellectual and creative achievement. Explorations of this age-old question have long sought to tease out the common features of geniuses working in different domains. The existence of unifying threads, including genetic factors, unusually broad interests, even a possible link with psychopathy, suggests that the mind of a genius has a discernible shape and disposition. Ultimately, the goal is to explain how an eminent thinker arrives at his or her world-changing moment, or moments of insight. Although such breakthroughs often seem to appear in a flash, the underlying mechanisms are likely to be much more orderly. According to one theory that Scientific American author Dean Keith Simonton helped to develop, a genius hunts widely for a solution to a problem, exploring dead ends and backtracking repeatedly before arriving at the ideal answer. This line of research is helping us to investigate whether genius can be cultivated, unleashing a wealth of new ideas for the benefit of all. In 1926, Catherine Cox estimated the IQs of 301 eminent individuals. Using biographical data on early intellectual development, she and her collaborators calculated IQ using the formula IQ equals mental age divided by chronological age times 100. Some representative results are shown here. These rankings illustrate the value of using achieved eminence rather than intelligence test scores as a measure of genius. Philosopher George Berkeley, for example, did not leave a greater mark on the world than Newton or Leonardo. Further, 8 of these creative geniuses have IQs below the genius threshold of 140. The first hurdle in the study of genius is to settle on a working definition. The word itself originated in ancient Roman mythology, according to which every male was born with a unique genius that served as a kind of guardian angel, and every female had a Juno. Much later, after the Renaissance, the world became more exclusive in its application, with only a few people showing genius. Philosopher Immanuel Kant believed, for example, that a genius was someone who produced works that were both original and exemplary. The term did not acquire scientific meaning until the late 19th century, when psychologists came to define genius in 2 distinct ways. The first approach was to identify genius with exceptional achievement, as Kant did. These accomplishments elicit admiration and emulation from other experts in that field, and often the world at large. Unquestioned examples of such works include Newton's Principia, Shakespeare's Hamlet, Tolstoy's War and Peace, Michelangelo's Sistine Chapel frescoes, and Beethoven's Fifth Symphony. Even though this definition can be extended to encompass extraordinary leadership or prodigious performance, most scientific research concentrates on outstanding creativity within the sciences or the arts, which will also be the focus here. The second definition of genius coincided with the emergence of intelligence tests in the first half of the 20th century. A genius was someone who scored sufficiently high on a standard IQ test, usually landing in the top 1% with a score above 140. These two definitions have little in common. Many people with superlative IQs do not produce original and exemplary accomplishments. One example is Marilyn Vos-Savant, who was once certified by the Guinness Book of World Records as having the highest recorded IQ of any living person. Her weekly Ask Marilyn column for the Parade Sunday newspaper supplement did not inspire a new genre of science or art, and many exceptional achievers do not attain genius-level IQs. Too often, genius is conceived as a discrete category. This person is a genius, but that person is not. Yet, just as people can vary in IQ, they can also differ in the magnitude of their creative achievements, with either a single notable contribution or a lifetime of prolific work. One such one-hit wonder is Gregor Mendel, who attained lasting fame for a single paper that reported his classic experiments in genetics. Had Mendel never taken an interest in breeding peas, his name would be unknown today. Charles Darwin's fame, in contrast, rests on far more than on the origin of species. Nobel laureate Max Born once said that Einstein would be one of the greatest theoretical physicists of all time, even if he had not written a single line on relativity. Hence, Darwin and Einstein exhibited greater genius than did Mendel. Accordingly, much research is devoted to assessing relative degrees of genius, most often gauged by creative productivity. Finding the sources of creativity has occupied the minds of philosophers and scientists for centuries. In 1693, English poet John Dryden wrote, "Genius must be born and never can be taught." 2.5 centuries later, French author Simone de Beauvoir countered, "One is not born a genius, one becomes a genius." The first scientific investigation devoted exclusively to genius concerned this precise issue. In 1869, Francis Galton published Hereditary Genius, in which he argued that genius is innate, based on his observations that geniuses tend to emerge from lineages that included other brilliant individuals. In response to criticisms, Galton later introduced the distinction between nature and nurture, one's lineage or environment. He conducted a survey of famous English scientists to discover some of the environmental variables involved in nurturing brilliance, and he examined factors such as birth order and education. By the second half of the 20th century, psychologists had moved to an extreme nurture position, in which creative genius rested solely on the acquisition of domain expertise. This idea was frequently expressed as the 10-year rule. Nobody can expect to reach the heights of creativity without mastering the necessary knowledge and skill, because only experts can create, or so the thinking went. Indeed, Einstein learned lots of physics before he commenced his creative career. This explanation cannot account for all the details, however. First, geniuses often spend less time acquiring domain expertise than their less creative colleagues do. Studies have linked accelerated acquisition with long, prolific, and high-impact careers. The 10-year rule is an average with tremendous variation around the mean. Also, major breakthroughs often occur in areas where the genius must create the necessary expertise from scratch. Telescope-based astronomy did not exist until Galileo pointed his new instrument toward the night sky. The new tool revealed what had never been seen before or even expected. The moon had mountains, Jupiter had moons, and the sun had spots. Second, geniuses are more likely to exhibit unusually wide interests and hobbies and to display exceptional versatility, often contributing to more than one domain of expertise. This tendency was true in the Renaissance, and it's evident today. According to a 2008 study, Nobel laureates in science are more involved in the arts than are less eminent scientists. Given that geniuses might not sleep any less than the rest of us, these extraneous activities would seem to distract from a dogged focus on a narrow field of interest. Einstein slept even more hours than the norm, but he still took time off to play Bach, Mozart, and Schubert on his violin. At times, these hobbies inspire major insights. Galileo was probably able to identify the lunar mountains because of his training in the visual arts, particularly in the use of chiaroscuro to depict light and shadow. The expertise acquisition theory also undervalues the genetic components of some cognitive abilities and personality traits that correlate with genius. In a 2008 meta-analysis, Dean Keith Simonton found that at least 20% of the variation in creativity could be attributed to heredity. For example, creative achievement is strongly associated with the personality trait of openness to experience, which is a highly heritable characteristic. The broad interests in art and music of many geniuses are clear manifestations of this trait. Many other predictors of achievement also have high heritabilities, such as cognitive and behavioral flexibility, along with a tolerance of ambiguity and change. Nurture still accounts for the lion's share of genius, and mastering a domain remains central. But genetics seems to contribute to the rate at which somebody acquires the necessary skills and knowledge. Some people can improve faster, launch their careers earlier, and be more productive. In addition, genetics may help explain the different trajectories of equally well-trained individuals. Einstein did not know as much physics as many of his contemporary theoretical physicists, but he knew enough. He could honestly say, imagination is more important than knowledge. These are just a few ways genetics might shape the potential for genius. A lot of studies have looked for intelligence genes without a lot of success. In a 2018 study, researchers analyzed DNA samples from 1,238 people recruited from the Duke University Talent Identification Program, an organization dedicated to identifying and fostering the development of academically talented children. The average IQ for the general population is 100. The average for this group was around 170, putting them in the top 0.03%. The researchers found a modest relationship between high IQ and the likelihood of having a few certain genetic variants, but basically, extremely intelligent people shared the same genetic makeup as the general population. As neuroscientist Richard J. Heyer discusses in his 2017 book, The Neuroscience of Intelligence, other intelligence research is combining molecular, genetic analyses, and neuroimaging. In one study, using a sample of 1,583 adolescents, researchers looked for a genetic variant related to how well neurons register new input, and found that it was related to both intelligence test scores and to the thickness of the brain's gray matter. What about other biological factors? Does a bigger brain make you smarter or wiser? Such correlations were difficult to establish in the past, but with structural MRI imaging of brain anatomy, such measurements are now routine. In healthy volunteers, total brain volume weakly correlates with intelligence and accounts for between 9 and 16% of the overall variability in general intelligence. Functional MRI scans, used to look for brain areas that are active during particular mental activities, reveal that the size of the parietal, temporal, and frontal regions of the cortex, along with the thickness of these regions, correlate with intelligence, but again, only modestly so. Thus, on average, a bigger brain is associated with somewhat higher intelligence, but whether a big brain causes high intelligence, or more likely, whether both are caused by other factors, remains unknown. Recent experiments focus on the connections among neurons in different regions of a person's brain, kind of like a neural fingerprint. These neuronal connections do better at predicting what's called fluid intelligence, which is the capacity to solve problems in a novel situation, to find and match patterns, to reason independently of specific domains of knowledge. They explain about 25% of the variance in fluid intelligence from one person to the next. But brain size or neuron number can't explain most of genius. There is no difference in average IQ between men and women, but an adult man's brain is 150 grams heavier than a woman's on average. In the neocortex, the part of the forebrain responsible for perception, memory, language, and reasoning, this disparity translates to 23 billion neurons for men versus 19 billion for women. It is also well established that Neanderthals had a cranial capacity that was 150 to 200 cubic centimeters bigger than that of modern humans. Yet despite their larger brain, Neanderthals became extinct between 35,000 and 40,000 years ago, probably because they were displaced by modern humans. What's the point of having big brains if your small-brained cousins outcompete you? Researchers have long been tantalized by the question of whether genius comes at a price. Greek philosopher Aristotle supposedly said, "Those who have become eminent in philosophy, politics, poetry, and the arts have all had tendencies toward melancholia." This idea received wide currency in the 19th and 20th centuries at the hands of psychiatrists and psychoanalysts. Among the great writers, Virginia Woolf, Anne Sexton, and Sylvia Plath died by suicide. Vincent van Gogh did as well. Newton sometimes suffered from extreme paranoia, and Galileo, possibly an alcoholic, suffered from depression. Nevertheless, many psychologists have argued that such cases are the exceptions, not the rule. Some psychologists find that creative genius is a human strength or virtue. Some studies with varied methodologies suggest that there is an association between genius and mental illness. Very creative writers tend to obtain higher scores on the psychopathology-related parts of the Minnesota Multiphasic Personality Inventory, a widely used test. A study using another instrument called the Eysenck Personality Questionnaire found that extremely creative artists, and high-impact psychologists for that matter, tend to receive elevated scores on the test's psychoticism scale, meaning that they are, among other things, egocentric, cold, impulsive, aggressive, and tough-minded. Last, highly eminent scientists tend to score higher on sections of the Cattell 16 Personality Factor Questionnaire that signify they are withdrawn, solemn, internally preoccupied, precise, and critical. Psychiatric studies bolster these results. The rate and intensity of symptoms such as depression and alcoholism are higher in very creative people than in the general population. Research also suggests that these divergent thinkers are more likely to come from family lines that are at higher risk for psychopathology. Psychosis, however, can shut down creative genius. This was dramatically illustrated in the 2001 film A Beautiful Mind, the biopic about the late Nobel laureate John Nash and his struggles with schizophrenia. To quote Dryden, "Wits are sure to madness near allied, and thin partitions do their bounds divide." Research conducted by psychologist Shelley Carson of Harvard University and her colleagues sought to identify these thin partitions. Creative achievement is positively associated both with cognitive disinhibition, openness to supposedly extraneous ideas, images, and stimuli, and higher intelligence and greater working memory. These mental capacities can potentially ameliorate the negative effects of cognitive disinhibition and even channel them to more useful ends. This synergy may well constitute the cognitive basis for serendipity. Not everyone would be able to work out the profound implications of such routine events as water overflowing a bathtub or an apple falling down from a tree, but Archimedes and Newton apocryphally did. Archimedes and Newton both worked in scientific fields, raising the possibility that their brands of creativity may have been similar. A more revealing question might be to investigate how their route to original thought compares with that of a superlative writer or musician. A physicist's way of thinking has little, if anything, in common with that of a painter. For example, learning how to solve a differential equation has as much utility for a painter as learning linear perspective has for a physicist, which is zero in most cases. Yet the themes uniting geniuses suggest that a common creative principle may exist. Domain expertise, such as the knowledge of advanced problem-solving strategies, supports thinking that is routine, even algorithmic. It does not inherently lead to the generation of novel, useful, and surprising ideas. Something else must permit a person to go beyond tradition and training to achieve genius. According to a theory proposed in 1960 by psychologist Donald Campbell, creative thought emerges through a process or procedure he termed blind variation and selective retention, or BVSR. In short, a creator must try out ideas that might fail before hitting on a breakthrough. Campbell did not precisely define what counts as a blind variation, nor did he discuss in any detail the psychological underpinnings of this process. Using a mixture of historical analyses, laboratory experiments, computer simulations, mathematical models, and case studies, Dean Keith Simonton developed BVSR into a comprehensive theory of creative genius. The blindness of BVSR merely means that ideas are produced without foresight into their eventual utility. The creator must engage in trial and error or generate and test procedures to determine the worth of an idea. Two common phenomena characterize BVSR thinking: superfluity and backtracking. Superfluity means that the creator generates a variety of ideas, many of which turn out to be useless. And backtracking signifies that the creator must often return to an earlier approach after going off in the wrong direction. Superfluity and backtracking are often found together in the same creative episode. Exploring the wrong track requires a return to options that had been originally cast aside. The reflections of Hermann von Helmholtz, a prolific physicist who made numerous creative breakthroughs, capture this process of discovery. I had to compare myself with an alpine climber who, not knowing the way, ascends slowly and with toil, and is often compelled to retrace his steps because his progress is stopped. Sometimes by reasoning and sometimes by accident, he hits upon traces of a fresh path, which again leads him a little further, and finally, when he has reached the goal, he finds to his annoyance a royal road on which he might have ridden up if he had been clever enough to find the right starting point at the outset. This account of venturing blindly into uncharted territory and retracing steps resonates with evidence from other eminent creators. As Einstein once said, if we knew what we were doing, we wouldn't call it research. Only further research can expand the theory into a comprehensive, predictive model whose claims can be thoroughly tested. Even so, BVSR can help us make sense of certain quirks of creative geniuses, including their personality traits and developmental experiences. Although they devote considerable time to achieving expertise, they also pursue other hobbies. Their openness to new ideas and their breadth of interests infuse them with seemingly irrelevant stimulation that can enrich blind variations. As 19th century German philosopher Arthur Schopenhauer said, "Talent hits a target no one else can hit. Genius hits a target no one else can see." Exceptional thinkers, it turns out, stand on common ground when they launch their arrows into the unknown. If you don't use your muscles, they weaken. Your brain also stays in better shape when you exercise. And not just challenging your mind by learning a new language, doing crosswords, or taking on other intellectually stimulating tasks. Researchers are finding that physical exercise is critical to vigorous brain health. The idea of exercising cognitive machinery by performing mentally demanding activities is called the use it or lose it hypothesis. But dozens of studies show that maintaining a mental edge requires more than that. Other things, including regular exercise, staying socially engaged, and even having a positive attitude, have a meaningful influence on cognitive functioning as people age. Further, the older brain is more plastic than is commonly known. The stereotype that old dogs can't learn new tricks is outdated. Although older people generally take longer to learn new pursuits and cannot reach the peaks of expertise that they might have achieved if they had started at a younger age, they can dramatically improve their cognitive performance through practice. As John Adams, the second U.S. president, put it, "Old minds are like old horses. You must exercise them if you wish to keep them in working order." The news comes at a propitious time. The proportion of older adults in the US and in other industrial nations is growing as life expectancy improves. In 1900, 4.1% of US citizens were older than 65. By the year 2000, that had jumped to 12.6%. By 2030, an estimated 20% of us will be in that category. Maintaining optimal cognitive functioning promises to enhance our quality of life through the years. How to keep minds keen over an entire lifespan is a question philosophers have posed since the earliest writings on record. As Roman orator Cicero put it, "It is exercise alone that supports the spirits and keeps the mind in vigor." Modern research in this field began in the 1970s and 1980s with studies that demonstrated that healthy older adults can improve performance to a greater extent than had been previously assumed. The earlier research did not fully address certain questions, such as how long adults could retain the new skills they had acquired through training, whether those specific skills would also improve other areas of cognition needed in everyday life, and whether the studies done with small numbers of subjects would be broadly applicable. Recent research suggests that cognitive training can lead to substantial benefits for older adults on the tasks trained, and some of these benefits are maintained over time and may transfer to other tasks. Toward the end of the 20th century, the National Institute on Aging funded a consortium of researchers to conduct a large-scale training study in a sample of older Americans. In 2002, psychologist Carleen Ball of the University of Alabama at Birmingham and her colleagues published results on more than 2,500 participants older than 65 who had received about 10 sessions of cognitive training. They were randomly assigned either to a cognitive process training group to learn how to excel in one of three areas: memory, reasoning, or visual search, or to a control group of subjects who did not receive training. At a follow-up 2 years later, the team randomly selected a set of the initial participants for booster training prior to evaluation. The results showed strong training effect sizes in each group as compared with the controls. In retests 5 years later, measurable training benefits were still present. More impressive, however, are recent training studies that focus on what psychologists call working memory and executive functions: how people plan a strategic approach to a task, control what they pay attention to, and how they manage the mind in the process. Psychologist Chandra Malika Basak, then at the University of Illinois, and her colleagues showed that training in a real-time strategy video game that demands planning and executive control not only improved gaming performance, but also enhanced performance on other tasks measuring aspects of executive control. Some studies have also increased the amount of practice provided. For instance, Florian Schmiedek and Ulman Lindenberger of the Max Planck Institute for Human Development in Berlin and Martin Lövden of the Karolinska Institute in Stockholm asked 101 younger and 103 older adults to practice 12 different tasks for 100 days. Both younger and older adults showed general improvements in working memory. You do not have to have specialized training, however, to achieve cognitive gains or ward off cognitive decline. Everyday activities such as reading can help. We reviewed evidence on activity-related cognitive enrichment in more than a dozen studies. Robert S. Wilson and his colleagues at Rush University Medical Center in Chicago recruited more than 4,000 elderly residents from a geographically defined community and rated their frequency of participation in 7 cognitive activities, such as reading magazines. At 3-year intervals for an average of nearly 6 years, participants completed an in-home interview that included brief tests of cognitive function. More frequent cognitive activity at the outset was associated with a reduced rate of cognitive decline over time. Over the past decades, several studies have underscored the link between physical activity and cognition. For instance, neuropsychiatrist Christine Yaffe of the University of California, San Francisco, and her colleagues recruited 5,925 women older than 65 at 4 different medical centers across the U.S. The researchers assessed their physical activity by asking the women how many city blocks they walked and how many flights of stairs they climbed daily, and gave them a questionnaire to fill out about their levels of participation in 33 different physical activities. After 6 to 8 years, the researchers assessed the women's level of cognitive function. The most active women had a 30% lower risk of cognitive decline. Interestingly, walking distance was related to cognition, but walking speed was not. It seems that even moderate levels of physical activity can serve to limit declines in cognition. Moderate movement is good, but toning your circulatory system with aerobic exercise may be the real key to brain fitness. In a study of 1,192 healthy 70 to 79-year-olds, cognitive neuroscientist Marilyn Albert of Johns Hopkins University and her colleagues measured cognition with a battery of tests of language, verbal memory, nonverbal memory, conceptualization, and visuospatial ability. They found that the best predictors of cognitive change over a 2-year period included strenuous activity and peak lung flow. A study by epidemiologist Jennifer Weaver, then at Harvard University, and her colleagues examined the relationship between physical activity and cognitive change over a 2-year period in 16,466 nurses who were older than 70. Participants logged how much time they spent per week in a variety of physical activities, such as running, jogging, walking, hiking, racket sports, swimming, bicycling, aerobic dance, over the past year, and provided self-reports of walking pace in minutes per mile. Weaver's group observed a significant relation between energy expended in physical activities and cognition across a large set of cognitive measures. Most research thus far has examined mental performance over relatively short periods of just several years. A few studies have begun to look at what happens over longer timescales. Suvi Rovio, now at the University of Turku in Finland, and her colleagues examined the relationship between physical activity at middle age and the risk of dementia an average of 21 years later, when the cohort was between 65 and 79 years of age. Subjects indicated how often they participated in leisure time physical activities that lasted at least 20 to 30 minutes and caused breathlessness and sweating. Conducting such activity at midlife at least twice a week was associated with a reduced risk of dementia in later life. Indeed, participants in the more active group had 52% lower odds of having dementia than the more sedentary group did. Kirk Erickson and his colleagues at the University of Pittsburgh assessed self-reported physical activity alongside measures of regional brain volume. They reported an association between walking and retention of brain volume, which in turn predicted a reduced risk of dementia in 299 older adults over a period of 13 years. Interestingly, it is not just aerobic forms of physical activity, such as walking, jogging, swimming, and bicycling, that have been associated with improvements in cognition. Teresa Lou Ambrose, a professor of physical therapy at the University of British Columbia, found that resistance exercise improved aspects of executive control in older women. Why would physical activity have such an effect on mental abilities? It may have to do with the link between physical activity and disease. Physical activity reduces the risk of cardiovascular-related death, type 2 diabetes, colon and breast cancer, and osteoporosis. Cardiovascular disease and diabetes in particular have been associated with compromised cognition, so exercise could maintain cognition by reducing the risk of diseases associated with cognitive decline. Psychologist Stanley J. Colcomb, then at the University of Illinois, and his colleagues examined the influence of fitness training on potential changes in brain structure. The 6-month trial included 59 healthy but sedentary volunteers aged 60 to 79. Brain scans after fitness training showed that even relatively short exercise interventions can begin to restore some of the losses in brain volume associated with normal aging. Kirk Erickson and his colleagues found that an hour a day for 3 days a week over the course of a year increased the volume of the hippocampus in older adults, which is a part of the brain that is crucial for memory. Researchers have found that brain regions that need to communicate with one another to support memory, reasoning, and problem solving become more poorly connected as we age. A study by Michelle Voss of the University of Illinois and her colleagues found that when older adults participated in a 6-month walking program, connections increased in a number of brain networks, And this increased connectivity was associated with improvements in executive control processes, such as scheduling, planning, dealing with ambiguity, and working memory. Together, all these studies suggest cognition, brain structure, and function improve in response to improvements in fitness. Doing puzzles and push-ups are helpful for some, but other factors also boost mental fitness. Getting involved in social groups both improves cognition in general and seems to delay the onset of dementia. The traditional focus of this research has been on relatively objective measures of social isolation versus connectedness, including the extent to which a person participates in activities that prominently involve social interactions, such as doing volunteer work, the number of friends and relatives an individual communicates with regularly, or in other words, the size of a person's social network, and their marital status. Some findings suggest positive attitudes and beliefs improve adult cognition, but those results are spottier. Positive beliefs and attitudes may have indirect effects by influencing behaviors such as exercise and mentally stimulating activities that are associated with cognitive enrichment. More generally, people who are optimistic, agreeable, open to new experiences, conscientious, positively motivated, and goal-directed are more likely to age successfully, to take advantage of opportunities, to cope effectively with life circumstances, to effectively regulate emotional reactions to events, and to maintain a sense of well-being and life satisfaction in the face of challenge. Just as some activities may reduce the risk of cognitive decline, other patterns of behavior may increase the risk. Chronic psychological distress, resulting from depression, anxiety, and negative emotions such as anger and shame, is associated with a variety of negative outcomes in adulthood, including cognitive decline. The tendency to disproportionately experience psychological distress is called neuroticism. Studies have found a higher level of neuroticism to be linked to an increased risk of Alzheimer's disease and mild cognitive impairment in old age. Public policy should follow a health prevention model that takes this research into account. Supporting the elder hostel movement or adult continuing education could help older adults engage in intellectual activities. A critical issue is how to promote physical exercise and social interactions in midlife during the working years. Future research should address whether work-related activity programs, such as the availability of exercise facilities at or near the workplace, foster an enriching lifestyle. Before we end, it is important to know that there is some controversy about the magnitude and durability of mental exercise outcomes. Companies are marketing computer games and other means of exercising the mind, often making strong claims about the effectiveness of expensive products, claims that have not been backed by actual scientific studies. Consumers should look for evidence demonstrating the benefits of such products, particularly with regard to everyday activities such as driving, memory, and decision-making, and be especially wary of bold or miraculous claims. We may soon discover the potential for maximizing human performance through cognitive enrichment. Advances in medical science have led to increased longevity through effective treatments for many illnesses that increase the risk of dementia. Similarly, we hope, advances in psychological science can improve the quality of life and show how behavioral interventions can help us all age successfully. Take a moment to look at this image. What do you see? Just a neural network? Perhaps you spotted the hidden figure. If so, you have just had a moment of insight. You may have felt a similar jolt when discovering the solution to a math problem, understanding a joke or metaphor, or realizing something unexpected about yourself. These aha moments occur when your brain spontaneously reinterprets information to reach a novel, non-obvious conclusion. Nessa Bryce painted neurons a few years ago for an art exhibit. She had designed the piece to portray the idea that our brain's neural networks make us who we are. After joining psychologist James T. N's Vision Laboratory at the University of British Columbia in 2013, she had her own abrupt realization. She recognized how her art could inform science. Using this piece, along with other hidden object images, she investigated how a person's focus and attention change when experiencing an unexpected revelation. Creative people have sudden breakthroughs, instances when they are able to recombine information in a new and useful way. Scientists view these flashes of insight as markers of the creative process, and observing them in the laboratory elucidates what happens in the brain during problem solving. A story is emerging about all the factors that lead up to an insight, says cognitive psychologist John Cunios, who studies creativity at Drexel University. What researchers are finding is that the contemporary science of creativity largely bolsters an almost century-old theory. In 1926, political scientist Graham Wallas defined the creative process as 4 distinct stages: preparation, incubation, illumination, and verification. Since then, scientists have broken some of his stages into substages to reveal distinct cognitive processes. For example, preparation now consists of 2 parts, one involving general learning and the other more focused on skill building. These stages really seem to be universal, whether you are a scientist, artist, writer, or musician, says Harvard University psychologist Shelley Carson, who has interviewed more than 1,000 creative people for her research. And creativity is not restricted to a subset of highly talented artists and thinkers, Carson says. These innovative people have a distinct style of thinking, and breaking down their approach can allow anyone to recreate the process. Brain research has revealed that we can all get closer to achieving that magical spark of insight with the help of a few simple techniques. Roughly speaking, people solve problems in one of 2 ways. They either tend to rely on moments of insight, or they approach them analytically. Answering questions with analysis involves finding solutions through deliberate, methodical trial and error, whereas insight is perceived as an abrupt epiphany. Both methods are useful, but insight is typically seen as the best option for out-of-the-box solutions. Cunios and his colleagues monitored the brain activity of 26 study participants using electroencephalography, or EEG, while they sat quietly in a room. After recording these electrical signals, the researchers asked the participants to try to solve 180 anagram problems, which involved reorganizing a word such as west to form another word like stew. Subjects also reported whether they had used an insightful or analytical approach to solve each problem. Cunios found that the brain activity of people who used insight differed significantly from that of people who preferred the analytical approach. Before they even began solving problems, most members of the insight group exhibited less activity in the occipital lobe, a region involved in visual processing, compared with the analytical set. Specifically, the brains in the insight group showed less activity in the so-called alpha wave range, which reflects neural inhibition, and the beta 1 wave range, which is linked with selective visual attention. In other words, these findings suggest that people who rely on insight tend to experience diffuse visual attention when they're not actively engaged in a task. In a way, this study, along with Carson's reports from highly creative individuals, suggests that to prime your brain for creativity, you should wander the world with an open mind. Gathering a broad base of knowledge is the first stage of the creative process, which usually comes naturally to people through intellectual curiosity, Carson says. Another way to break your thought habits is by asking questions such as, how can I do this differently? And by stepping outside your comfort zone. A poet with writer's block, for example, might be advised to take up a new hobby such as scuba diving or dance lessons. Neuroscientist turned artist Greg Dunn discovered an entirely different way to depict the brain when he began studying sumi-e art, an Asian style of painting. His experimentation with the style's free-flowing ink led to a simple yet elegant new method for painting neurons. Yet simply exposing yourself to new things does not seem to be the full story. According to a study by Sergio Agnoli and his colleagues at the Marconi Institute for Creativity at the University of Bologna in Italy, how you engage thoughts that arise through new experiences is important for facilitating creativity. They found that people who can deliberatively engage in focused mental exploration come up with more original solutions to problems than those who reported little ability to control how their mind wanders. Therefore, building a solid foundation from which creativity can grow requires both exposing yourself to new experiences and intentionally engaging with the thoughts and feelings that arise as a result. Psychologist Dean Keith Simonton of the University of California, Davis has linked creativity with the acquisition of expertise. He compared the cumulative years of experience of 59 opera composers with their aesthetic success. He measured aesthetic achievement in 8 different ways, tallying the number of times an opera was recorded and performed in major opera houses, for example, as well as the number of pages devoted to the work in opera histories. Simonton found that a composer's years of musical experience were a powerful predictor of an opera's acclaim. He also found that if the composer had already created a number of other works within the same genre, this would actually hurt the opera's critical reception and legacy. In other words, solutions to great problems demand practice, skill, and study, yet creative solutions occur when someone applies their experience to new domains. Whether you are proving Fermat's last theorem or planning a birthday party, finding novel solutions involves a little advanced research. How much preparation you will need will vary, but the more you know about a problem, the better equipped you are to solve it. Some of the most creative minds in history were masters of their respective fields. Given that these people spent large amounts of time immersed in their studies, one of the best ways to maximize your creativity is to find an area you would like to develop an expertise in. Then begin to follow that passion. Once you have immersed yourself in a problem, the best way to come up with a creative solution is to stop consciously thinking about it. Kounios and his colleagues used functional magnetic resonance imaging to record the brain activity of 44 people as they solved 185 remote association problems. These word puzzles require finding a single word that can pull together 3 seemingly unrelated words. For example, the solution to foam, deep, and salt is sea. After finding an answer, the subjects reported whether they had solved the problem using insight or analysis. Kounios found that in the 2 seconds before a problem appeared, the insight users prepared for the challenge by shifting from their scattered outward attention to an inward focus. Puzzles solved insightfully were preceded by increased activation in the anterior cingulate cortex, a brain region that monitors internal attention to different ideas, among other things. In contrast, tasks solved analytically were preceded by significant activity in the occipital lobe, which handles visual processing. This increase indicates that the analytical solvers concentrated more on what they were looking at. Research from the University of Amsterdam and the University of Bologna in Italy has demonstrated that sleeping on a problem or stepping away from it and then immersing yourself in an alternative activity can help you unconsciously cultivate creative solutions. Taken together, the findings reveal a benefit to forcing your brain to shift gears or look within. One reason might be that your attention can then be captured by a surprising solution your unconscious mind has been ruminating on. So take a nap or try your hand at something new. History is replete with examples of creative individuals who describe being hit with inspiration while daydreaming or attending to a different task. Writer Robert Louis Stevenson and musician Paul McCartney, for instance, used dreams as starting points for new works. Many day-to-day problems can be solved this way, which explains why so many people recall stumbling on ideas while taking a shower, or driving to work, or walking. When insight hits, certain changes happen in the brain. Psychologist Mark Beeman of Northwestern University led a study that measured people's brain activity with fMRI and EEG during the moment of insight. As in Kunios' studies, participants tackled remote association problems and then indicated if they had cracked the problem using insight. The results showed significantly increased activity in the anterior superior temporal gyrus of the right hemisphere at the critical moment when the solution appeared, in comparison to problem solvers who did not experience such an aha moment. This gyrus is a prominent ridge on the cortex of the right hemisphere, and it plays a fundamental role in recognizing distant connections between words. The activity surge in the right but not the left lobe may also be meaningful. According to the researchers, there are areas in the right side of your brain that interpret information more loosely than areas on the left side. This means that the information is less tightly defined, allowing you to access other concepts more readily, which is a key component of creativity. Both hemispheres are working all the time, but parts of your right hemisphere might loosely define a cat as a mammal, making it easy to see how a cat relates to, say, an elephant. Parts of your left hemisphere, however, might describe a cat as a small carnivorous mammal with soft fur, a short snout, and retractile claws, something very different from an elephant. Research has suggested that you can tip the scales toward a looser style of understanding by describing objects or issues in unusual ways. For example, by thinking of a hanger as a long twisted wire instead of as a metallic instrument for hanging coats, you might discover other uses for it. Try this technique every so often as you are actively working to solve a problem. It might help prime your brain to forge connections between distant concepts. The moment of insight is also accompanied by a burst of alpha activity in the visual cortex, according to Beeman's study. Alpha activity inhibits neuron firing, meaning that during a breakthrough, your brain is less involved in processing visual information, perhaps because visual stimuli can be distracting. These findings suggest that you could help your brain discover an insight simply by closing your eyes. Probably the most famous moment of insight in history is Archimedes' Eureka. Legend has it that the ancient Greek mathematician had been challenged to figure out whether a crown that King Hero II of Syracuse had commissioned was made out of solid gold. Archimedes was preparing a bath when he discovered how to measure an object's volume and thus its density after noticing the displacement of water as he climbed into the tub. Although the story may be apocryphal, it has gone down in history in part because it illustrates perfectly how insight strikes. Once you have had a moment of insight, you might find yourself feeling elated. A study by Tufts University researcher Tad Brunier showed that subjects who came up with broad associations between words, such as associating pipe with flute rather than smoke, experienced a boost in mood. Take advantage of the positive mood to check whether your solution works. When you have an insight, it comes with a lot of conviction, Carson says, so you really have to be objective and evaluate that idea. This stage is an ideal time to bounce ideas off of trusted friends. Their feedback and support could help you determine how well your solution works. We'll discuss how creativity is collective in an upcoming lecture. Do not be discouraged, though, if your personal eureka is less than perfect. Creative people often describe going through many failures before reaching a successful solution. Those failures help to inform the end result, making them a necessary step in the process. When a student asked chemist and two-time Nobel laureate Linus Pauling how he came up with so many good ideas, Pauling replied, "I have a lot of ideas and throw away the bad ones." In practice, each stage does not always follow easily from the one before it. Many people have to revisit earlier steps several times before hitting on inspiration, but ultimately the process is very rewarding. Creativity not only makes creators happy, but also benefits all those who will enjoy their creations. The joys of an aha moment may even serve a deeper purpose. In 2013, psychologists Claudia Muth and Klaus Christian Carbon of the University of Bamberg in Germany found that participants who identified a hidden face in a picture liked the image more than those who did not identify the face. Muth hypothesizes that insight is rewarding for evolutionary reasons. She says it could explain why we explore the world and why we have interest in things that are new. Being curious and pursuing creative endeavors provides you with the opportunity to discover new interests, explore unfamiliar territory, develop expertise, and take breaks. In short, working to develop and maximize your creativity serves to enrich your life. As Carson puts it, once you realize that you can be creative, it opens up this whole new world. The best actors, directors, and screenwriters receive Oscars. The top scientists get Nobel Prizes. Society doles out a multitude of awards every year to celebrate creative achievements. And such events feed a popular conception that creativity is a gift that only certain people possess, and that it is the height of individuality. As Albert Einstein once observed, everything that is really great and inspiring is created by the individual who can labor in freedom. In these terms, the constraints of groups and of mainstream society are often thought to kill creativity. Many see the notion of group creativity as an oxymoron. But let's think creatively here and challenge the basic assumption that the individual creator is the only critical component of the creative process. Let's consider the possibility that groups play an essential role in creativity, not only in generating and shaping novel things, but also in ensuring their appreciation and their impact. Although this idea might seem preposterous, it has garnered significant scientific support. S. Alexander Haslam, Immaculata Adarves-Yorno, Tom Postmus, and Lisa Jans reviewed the accumulated data in an article summarizing the current thinking about groups and creativity. They concluded that it is problematic and unhelpful to separate the creativity of individual minds from the communities in which they flourish. There's a romantic notion that innovation is achieved by rugged individuals working in splendid isolation. But research on personality has found no way to accurately forecast creative behavior. Scholars have scoured the biographies of creative geniuses to find experiences and character traits likely to have contributed to their greatness. Yet they have failed to identify characteristics that predict which young people will go on to become creative geniuses. These efforts lack predictive power because they do not take into account the important role that social context plays. The nature and significance of innovation depend on the interaction between a person's ideas and the time and culture in which he or she lives. If Dolly Parton had been born in 1746 rather than 1946, we would have been unlikely to ever hear Jolene. Likewise, if Italian composer Domenico Cimarosa had been born in 1949 rather than 1749, his nearly 80 operas, including the masterpiece Il Matrimonio Segreto, probably would not have seen the light of day. Such examples speak more generally to the influence that groups exert on creativity. In the 1970s, psychologists Henry Tajfel and John Turner of the University of Bristol in England developed the concept of social identity, observing that across a range of contexts, people understand themselves not only as individuals, but also as members of the groups they belong to. So a Cubist painter, we'll call him Pablo, may sometimes think of himself in terms of his personal identity, Pablo, but on other occasions, he will understand himself as a Cubist, his social identity. In yet other situations, his social identity might be defined with reference to his nationality, his gender, religion, or to his role in a specific team or club or organization. Tajfel and Turner argued that when a particular social identity is psychologically salient, such that it determines a person's sense of who he or she is, the group that is the basis for that identity will exert a profound influence on that person's behavior. Furthermore, the way in which that person evaluates an action will reflect shared understandings of that group. This idea also applies to creative behavior and its evaluation. For example, as a cubist, Pablo is more likely to be interested in and to appreciate abstract representations of objects, and he will be more likely to paint in accordance with cubist sensibilities and preferences. Social identities also grant people a shared perspective, as well as the ability and motivation to engage in mutual social influence. But when people act in terms of their unique personal identity, they are likely to display creativity by deviating from that norm. In an experiment that S. Alexander Haslam, Immaculata Adarves-Yorno, and Tom Postmus conducted, they asked some college students who were working in groups to create posters about reasons for going to university, and they asked other groups of students to make posters about fashion at university. These instructions implicitly led the students toward certain group norms. Those told to focus on reasons naturally made posters dominated by words, and those who were directed towards thinking about fashion created posters populated largely by images. In the second phase of the study, which came 3 hours later, the same participants created a leaflet to advertise the university, a task that could be accomplished equally well with words as well as with pictures. This time, some of the students worked in groups, whereas others made the leaflet on their own. Here, the researchers were interested in whether this creative task would be shaped by the group norm that had been established in the earlier phase, and it was. When working in a group, participants' creations were generally in line with the group norm that had been established during the poster-making project, whether it centered on images or on words. But when working individually, however, participants typically departed from the norm of the group they had previously belonged to. Such findings and those of similar studies support the claim that the nature of people's creative activity depends on group norms. Evidence that social identification shapes creativity might suggest that groups simply stimulate convergent thinking and conformity. Indeed, back in the 1970s, Irving Yannis of Yale University proposed that a desire to conform to the group leads to a lack of critical thinking and faulty decision-making, a phenomenon called groupthink that he considered the antithesis of creativity. But although group dynamics can sometimes be stifling or even worse, they do not inevitably produce irrational choices or unthinking support of the group's ideas. For one thing, group standards shape only one facet of a person's creativity. Cubist painters, for instance, may use abstract geometric figures in line with the customs of Cubism, but their artwork is likely to diverge on other dimensions, for example, in its use of certain colors or themes that are not restrained by the Cubist style. In addition, far from repressing new ideas, collaborative discussions with friends or colleagues or peers can foster them. As the late psychologist Vera John Steiner of the University of New Mexico noted in her 2000 book called Creative Collaboration, small groups such as the Beatles or Bauhaus or the Bloomsbury Group, for instance, routinely spearhead innovation by bouncing ideas off one another as they look for new ways to tackle artistic, theoretical, and practical problems. What is more, solidarity and conformity are essential for creative movements to progress because they allow people to cohere around a shared enterprise. In a study published in 2006, Haslam, Adarves-Yorno, and Postmes explored this idea by asking small groups of college students to participate in a mock planning process for building an innovative municipal childcare center. Prior to the study, some of the groups went through a procedure that instilled a strong sense of shared social identity, whereas other groups were encouraged to think of themselves as individuals. The groups then met 3 times over an hour and a half to discuss this fictitious project, which encountered mounting difficulties. First, labor costs increased, and then an environmental impact study was needed. Next, they learned that the children's sandbox had traces of toxic elements. Parents were threatening to sue, and officials were holding up building approval. The groups that had initially developed a shared social identity stayed upbeat about the project and continued to support it even as it ran into more and more trouble. On the other hand, those coaxed to see themselves as individuals lost their enthusiasm for the child care center and increasingly argued to abort the project as time went on. In other words, social, but not personal identity bolstered enthusiasm and encouraged people to stay with the creative task in the face of challenges. More generally, people seem to need a sense of shared social identity to stick to their creativity and to see revolutionary projects, whether they're in science, industry, the arts, or politics, to completion. Being solidly committed to the group does not make a person unable to recognize its faults either. Sometimes the opposite appears to be the case. When norms are harmful for a group, it is actually the members who feel most connected to the group who are the most motivated to debate and renegotiate those norms. Psychologists Dominic J. Packer of Lehigh University and Christopher T.H. Miners of Queen's University in Ontario asked students to write an opening statement before a meeting in which they were going to discuss alcohol use with their peers who tended to party. The researchers found that the more the participants identified with the group, the more their statements involved creative challenges to that group norm, possibly because those high identifiers felt the greatest responsibility to the group or the most able to effect a transformation. Either way, the research shows that engagement with groups can help stimulate creative ideas for change. Groups also play a vital role in the appreciation of groundbreaking achievements. Without tapping into group identity, innovative artists, writers, and scientists may well go unrecognized. In his lifetime, Vincent van Gogh could find hardly anyone to buy his unusual paintings. His work garnered attention only when, after his death, a circle of artists, the post-impressionists, saw his paintings as indicative of a distinctive style that they wanted to emulate in their own work. Similarly, in 1961, the computational models of then graduate student Yoshisuke Ueda were initially barred from publication by his supervisor at Kyoto University because they were seen as too avant-garde. But once a community of scientists had formed who appreciated Ueda's work, however, his theories transformed the newly emerging field of chaos theory. People are far more likely to support a creative project or endeavor if its instigator is a member of their group. Such insider status helps to dispel the uncertainty that new products introduce when they disrupt the status quo. Insiders and organizations are typically antagonistic towards outsiders' contributions, and people often display ethnocentric bias when judging artistic creativity. In the performing arts, judges may preferentially bestow accolades on citizens of their own country, for instance. Both the US Oscars and the British Academy of Film and Television Arts, or BAFTA, awards are meant to judge the objective quality of films. But psychologist Nicholas Steffens and his colleagues at the University of Queensland in Australia found that since 1968, US actors and actresses have received about 80% of the Oscars for Best Actor and Best Actress, but less than half of the BAFTA awards for the same categories. At the same time, British performers have received nearly half the BAFTA awards for Best Actor or Actress, but just over 10% of the corresponding Oscars. So experiments confirm that people's perceptions of creativity depend on whether the creator is one of us or one of them. In one study published in 2008, Haslam, Adarves-Yorno, and Postmes asked 50 people from the UK to evaluate suggestions about the future format of a television show that they said had come from a British website. They told another 50 participants that the same ideas had come from a Dutch website. In part 2 of the study, they asked 125 British students to evaluate the works of art that they attributed to either British or Dutch college students. In both cases, participants who thought their fellow Brits, their in-group, had authored the products in question judged them to be significantly more creative than did those told that Dutch citizens had generated the same items. What people actually mean by creativity and how they measure it and how they reward it also depends on cultural identity. Psychologists Susanna Palitz, now at the University of Maryland, and Kai-Ping Peng of the University of California at Berkeley conducted a survey that included more than 300 students from China and the US to find out what they thought made certain products creative. They tested two very different kinds of products, a course textbook and a meal cooked by a friend. They found that American students' judgments of creativity were swayed more by the perceived appropriateness of a product, whether it was, in some sense, good, whereas the judgments of the Chinese students were based more on whether the product was something that they personally desired. The tendency for creativity judgments to reflect our social identities also explains some gender bias. Psychologist Thomas Morton and his colleagues at the University of Exeter in England reported that male scientists viewed theories explaining how men were superior to women to be better and more creative than those arguing that women were superior to men. This pattern was reversed for female scientists. Both groups also believed that the creative research that supported their own identity-based preferences was deserving of more research funding. Good creators have a strong sense of their audience and gear their solutions or products to the perceived needs and values of a particular group. Even when work is inspired by the need to separate from a group, successful creators are familiar with the group they wish to deviate from. For example, in the 1970s, punk rock bands such as the Sex Pistols wanted to break away from mainstream popular music. Sid Vicious, the Sex Pistols bassist, called on people to undermine the establishment's pompous authority, reject their moral standards, make anarchy and disorder your trademarks. Ironically, then, the musical establishment of the time gave his band a particular creative force, the desire to rebel, as well as a specific trajectory, something specific to move away from, and appeal for those disaffected with mainstream popular music. As with other successful creative efforts, the Sex Pistols' attempts to break the mold were not exactly random and revolutionary. As members of groups, our creative behavior and our evaluations of others' innovations reflect a desire to extend the values of those groups. To be celebrated rather than vilified, innovators need to know the norms they are departing from. Eventually, they also need an audience willing to embrace the new ways of seeing or behaving that's made possible by their work. To succeed, therefore, creative endeavors must transform communities. These newly formed audiences then drive the cultural change that novel endeavors spark. Pablo Picasso once said, "Disciples be damned. It's only the masters that matter, those who create." Yet, as the curators of a major exhibition at London's National Gallery noted, Picasso's own work owed much to earlier modes of painting that he eventually rejected. And without admirers, his work would have had little influence on society. His work was not about laboring on his own to create everything anew. Rather, as Welsh painter Ossie Rhys Osmond put it in a review of the exhibition, it was a collaborative exercise in reinventing the familiar. We should still study and celebrate the creative genius of individuals. Nevertheless, we need to recognize that the psychology of creativity also involves the groups in which creators develop their work, whose boundaries they seek to extend, and through which they have their sway. "I Did It My Way" may be an appealing anthem for great creators, but as with Frank Sinatra, their success generally also requires promoters, producers, a pack of peers, and an approving public. A commitment to gifted education is critical for nurturing young people who can make path-breaking discoveries and creative contributions to society. The first step is to train teachers and others to spot talent, which may show up in a child's IQ score, but could also surface as aptitudes in specific areas such as number sense or musical ability. Psychosocial skills that can be developed through training, such as persistence, strategic risk-taking, and self-regulation, also contribute to later success. Offering young children a wide range of activities could spawn new interests and enable a greater diversity of talents to surface. However, not all methods of spotting and nurturing talent are effective. And it is not clear that parents can supercharge their baby to boost his or her long-term abilities. At least that is what David Barner says. And he should know, he tried to supercharge his daughter. Barner is an expert in the development of math education for children. He knows that math learning is important for cognition and for life skills, so he wanted his 2-year-old daughter to be a math whiz. He was never great at math himself. Both he and his wife preferred reading, but he saw its value. So for months, he spent time each day quizzing his child using flashcards and videos, games and comic books to teach math to toddlers and preschoolers. In the end, although he delighted in watching a young mind absorb math in real time, that is pretty much all he got, while his daughter developed a distaste for math. Her true passion and skill? Reading, of course. Speaking with his professional hat on, Barner thinks that parents have less impact on their kids than things like who your friends are, what school you go to, whether you have access to good resources. Many analyses, such as an ongoing University of Minnesota study with separated twins, also show that personality and proclivities are surprisingly heritable. Once an exceptional aptitude emerges, we need programs to be in place, including accelerated classes and psychological coaching, that can nurture its development as early and as vigorously as possible. The chief goal of these efforts is preparing young people for outstanding achievement. For nearly a century, scholars have sought to understand, measure, and explain giftedness. To some, the term is a misnomer for the result of endless practice or social advantage. However, extraordinary abilities do exist and do matter. Giftedness implies an ability to perform at the extreme upper end of the distribution in any certain area. Early on, it is determined and largely defined by potential, followed by demonstrated achievements, and later by creative productivity or eminence. In elementary schools, it is often equated with IQ. Students who score above the 95th percentile on an intelligence test are often classified as gifted. IQ is generally predictive of achievement in school, but new research shows that narrower, subject-specific academic assessments can help forecast the likelihood of adult contributions to, say, literature or physics. In 2005, psychologist David Lubinsky of Vanderbilt University and his colleagues reported that scores on the math and verbal parts of the SAT measured at around age 13 in high-achieving students, as well as tests of student interests, can indicate whether an adolescent will choose to later pursue the humanities or a math or science field as a career. Even differences within the 99th percentile of scores for mathematical ability, the top 1%, are associated with variations in outcomes, such as a student's eventual income level, the number of patents and other creative accomplishments, and the likelihood of obtaining a doctorate. This longitudinal work is ongoing and has been replicated at Duke University. In recent years, educators have begun to look beyond IQ scores to measure giftedness. Specialized schools or programs for science or the arts admit students based on achievement test scores, essays, and projects. Elementary school programs may ask teachers to complete checklists that reveal a student's commitment to learning. As we discover how to better identify the core abilities associated with each domain of knowledge and skill, the field will move from relying primarily on current performance to using measures of potential, including psychosocial skills, as students get older. To achieve greatness in any realm requires more than talent. It also demands extraordinary creativity, self-regulation, and social skills. Creativity, the ability to come up with novel, useful, and elegant ideas or ways of doing things, has a long historical association with giftedness. It may depend on relevant skills and knowledge, but at its essence are mental processes such as metaphorical thinking, tolerance for complexity, and flexibility in problem solving. Precursors of adult creativity may include independent thinking, a willingness to entertain different perspectives and views, and the creation of projects and products that are novel when compared with those of one's peers. In 1999, educational psychologist Jonathan Plucker, now at Johns Hopkins University, reported results from a multi-decade follow-up of students who were identified as creative with the Torrance tests of creative thinking while they were in elementary school. Scores on this test, which largely measures divergent thinking, were 3 times better than IQ tests at predicting the quantity and quality of publicly recognized creative accomplishments in adulthood. Divergent thinking may be defined as an outside-the-box approach that generates unusual or creative alternatives to persistent challenges. In laboratory studies, DT is measured with tasks that require individuals to complete picture fragments with novel drawings or to generate alternative uses for common objects. For instance, turning a paperclip into a fishing hook or an earring. Although pondering different uses for a paperclip may seem somewhat frivolous on the surface, longitudinal studies of DT suggest that children's scores on these sorts of tasks predict their personal and professional creative achievements as adults. Thus, the ability to think divergently may be established early in life and may influence people's capacity for making meaningful, influential contributions at home or work. Aside from their ability and creativity, gifted individuals stand out in the commitment and sacrifice they are willing to make in pursuit of their goals. As psychologist Mihai Csikszentmihalyi wrote, the unifying similarity among geniuses and innovators is not cognitive or affective, but motivational. What is common among them is the unwillingness or inability to strive for goals everyone else accepts. Giftedness has long been associated with high levels of intrinsic motivation, that is, engaging in a task for the sake of learning. In fact, many high academic achievers are also motivated by and enjoy extrinsic factors such as trophies, scholarships, and other forms of recognition. In a 2010 study, school psychologist David J. Cover, then at the San Francisco Unified School District, and Frank C. Worrell showed that a group of academically talented students had similar levels of intrinsic and extrinsic motivation. High achievers may hunger more than others, not only for knowledge, but also for fame, fortune, or the power to change the world. In 1978, Joseph Renzulli introduced the idea that one of the most distinguishing features of high achievers is their task persistence and motivation. In other words, they are willing to engage in study and practice that, though not necessarily enjoyable, is instrumental to improvement. In a 2008 study, psychologist Timothy W. Kirby, now at George Mason University, and his colleagues, demonstrated that the kindergarten pupils most likely to be identified as gifted in 3rd grade exhibited not only high cognitive ability, but also early task orientation, which is the ability to do and complete work even in an environment in which teachers may not be directly supervising the work or when there are distractions present. Passion contributes to the development of great ideas and performances, although it has rarely been studied in the context of gifted education. In one exception, psychologist Jennifer A. Fredericks, then at Connecticut College, and her colleagues, examined the quality in a 2010 study of 66 high school and college students who had been identified as gifted in academics, sports, or the arts in childhood. The athletes and artists readily expressed passion about their involvement, telling experimenters, for instance, "I love the game. I want to play all the time." Among academically gifted youths, however, a typical statement was, "Well, I don't get all excited or anything. I mean, it's schoolwork." The study suggested that the way academics are currently taught does not instill passion. But with a greater focus on problem solving, creative thinking, and learning authentic methods of a discipline, we might better foster that passion among academically gifted students. Further, the students might have displayed interest in specific subjects if the survey had been structured that way. A key to developing intellectual talent may lie in giving students lots of opportunities to pursue their interests. In a 2010 study, Jonathan Y., then at Duke, and his colleagues assessed participation in various educational opportunities such as academic competitions, research apprenticeships, academic clubs, summer programs, and accelerated classes among 1,467 individuals who had been identified as talented in math at age 13. They found that those who had been involved in more of these activities and classes, which is what the authors called a larger educational dose, had at age 33 a higher rate of notable accomplishments in science, technology, or math, such as earning a PhD, obtaining patents, or securing tenure. Effective talent development requires different kinds of teachers at different stages. Mentorship is vital for transforming ability into renown. In a study of the origins of eminence through mentorship published in 1977, sociologist Harriet Zuckerman of Columbia University interviewed 92 Americans who had won a Nobel Prize in Science between 1901 and 1972. She found that more than half the interviewees had studied or collaborated with previous laureates. These mentors helped their protégés develop a feel for important problems and elegant solutions and mobilized resources, such as access to grants, fellowships, jobs, and publications on their behalf. Developing youthful talents, especially in low-income and rural communities, by extending and supplementing the regular curriculum, can expose children to new topics and ideas and enable them to engage with a subject in more depth. Summer programs, for example, may feature a range of topics that are not typically available in the regular classroom, such as human anatomy for fourth graders or robotics for middle schoolers. Such enrichment activities are a staple of most gifted programs in schools, but expanding them could identify new talent. Courses that introduce subjects typically not studied until high school or college, for example, may give interested and able students a head start. In some cases, students may take these courses in specialized schools for gifted students, such as the Illinois Mathematics and Science Academy and New York City's Brooklyn Technical High School or the Bronx High School of Science. The greater the diversity of offerings, the greater are our chances of unmasking potential. In 2004, the news program 60 Minutes ran a piece on low-income adolescents of color from Harlem, 4 of whom were representing the United States at the Olympics in fencing that year. How did students from low-income backgrounds living in an inner-city neighborhood get involved in such an esoteric sport? By good fortune, a black fencing champion had retired to Harlem and begun giving lessons 15 years earlier. His work provided the opportunity for many youngsters who may never have had a sword to discover that they had a talent for the sport, as well as the interest, the passion, and the commitment to pursue it. Students who seize such opportunities and demonstrate sufficient commitment should be given access to increasingly challenging classes or competitions, regardless of their age. Academic acceleration may involve skipping a grade, entering a higher grade level in a single subject, or enrolling early in advanced placement courses. It may also consist of speeding up instruction in a course so that 2 years of material are covered in 1 year. Acceleration significantly boosts both achievement and motivation in gifted students. Several meta-analyses reported in 2004 by psychologist James A. Kulik found that accelerated elementary and secondary students demonstrated levels of achievement superior to mainstreamed gifted students of the same age and ability. Kulik also found that accelerated students were more likely to seek degrees beyond a bachelor's. Researchers Tsai-Ying Steenberg and Hu, Matthew C. Makel, and Paula Olszewski-Kubilius conducted a meta-analysis of the effects of acceleration based on 6 previous meta-analyses. Results showed that the accelerated students significantly outperformed their non-accelerated same-age peers to at least a moderate degree, although their performance was not significantly greater than that of the non-accelerated older peers. When different forms of acceleration were studied separately, such as grade skipping or compressing curriculum into shorter periods, results were similar, with positive, moderate, and statistically significant impact of acceleration on students' academic achievement. Schools hardly ever use acceleration strategies, yet acceleration should be a key part of gifted education. Indeed, we can expect children with talent to increasingly channel their efforts into specific areas as they mature. They may be able to do so by buying time for enrichment, apprenticeships, and other exploratory programs through showing early mastery of content. Students benefit from schools staffed with extremely knowledgeable teachers, even at the earliest grades. And we need more affordable summer programs that compress semester-long or year-long courses into a few weeks of intensive instruction. Providing opportunities is not enough, however. Talented individuals must take advantage of them. Research shows that young people may shy away from educational or extracurricular offerings for various reasons, including fear of competition or failure, poor study and organizational skills, and shyness. Capitalizing on favorable circumstances thus requires certain psychological strengths, among them an ability to cope with challenges and criticism and a willingness to take strategic risks. Such traits, along with persistence, focus, and drive, also support the ability to undergo the intense practice and preparation necessary to reach the top. In a 2001 study, sports psychologist Daniel Gould of Michigan State University and his colleagues investigated the development of psychological strength in U.S. Olympic champions. Becoming a champion requires more than just athletic prowess. It also depends on an ability to focus, mental toughness, facility with setting goals, competitiveness, confidence, coachability, drive, optimism, and emotional control. Coaches routinely teach elite athletes how to handle setbacks, adjust anxiety levels for optimal performance, and imagine success. In recent years, music conservatories have given more systemic attention to these skills. The Juilliard School's pre-college and conservatory programs implicitly inculcate values such as deep devotion to one's art and teachers that are associated with successful negotiation of the conservatory years. The school has also offered courses on mental skills training to directly address variations in outcome from music star to underachiever. Academically talented students can experience competitive and occasionally stressful environments. Although these individuals often display extraordinary motivation and commitment, they rarely receive additional psychological coaching to deal with the rigors of acceleration, peer comparisons, and other challenges. Schools and college teachers receive no systematic training in this realm. Neither are they typically trained to boost creativity through exercises that invigorate metaphorical and divergent thinking or problem solving. Schools could do more to encourage high academic achievement too. Although teachers and administrators often publicly recognize accomplishments in athletics, leadership, and the performing arts, they tend to ignore or downplay academic feats. Stereotyping kids with intellectual talents as nerds or brainiacs betrays a lack of support for these children, many of whom work very hard to meet their goals. It may also send a message to other students that high achievement is not worthy of teacher attention or recognition. Indeed, the idea that gifted children are naturals and do not need to study or practice can severely undercut motivation. According to research by psychologist Carol S. Dweck of Stanford University, the assumption that intelligence and talent are fixed traits can lead people to focus primarily on proving themselves worthy of their gifted or smart label and to undervalue the role of effort in achievement. In contrast, believing that intelligence and talent are malleable can motivate a person to put in the daunting amount of effort necessary to achieve goals such as becoming a respected physicist, historian, or philosopher. Dweck's research suggests that this attitude can be fostered with proper instruction and parenting practices. The world needs more people who can develop extraordinary skills and insights. When children are given the means to transform talent into transcendent achievement, they experience great personal satisfaction and at the same time can deliver benefits to society that we can't even predict. 5 common myths about the brain. Some widely held ideas about the way children learn can lead educators and parents to adopt faulty teaching principles. Myth: humans use only 10% of their brain. Fact: the 10% myth, which is sometimes elevated to 20%, is mere urban legend. It's one perpetuated by the plot of the 2011 movie Limitless, which pivoted around a wonder drug that endowed the protagonist with prodigious memory and analytical powers. In the classroom, teachers may entreat students to try harder, but doing so will not light up unused neural circuits. Academic achievement does not improve by simply turning up a neural volume switch. Myth: left brain and right brain people differ. Fact: the contention that we have a rational left brain and an intuitive, artistic right side is fable. Humans use both hemispheres of the brain for all cognitive functions. The left brain, right brain notion originated from the realization that many, though not all, people process language more in the left hemisphere, and spatial abilities and emotional expression tend to be more in the right. Psychologists have used the idea to explain distinctions between different personality types. And in education, programs emerged that advocated less reliance on rational left brain activities. Brain imaging studies show no evidence of the right hemisphere as a locus of creativity, and the brain recruits both left and right sides for both reading and math. Myth: you must speak one language before learning another. Fact: children who learn English at the same time as they learn French do not confuse one language with the other and develop more slowly. This idea of interfering languages suggests that different areas of the brain compete for resources. But in reality, young children who learn 2 languages, even at the same time, gain a better generalized knowledge of language structure as a whole. Myth: brains of males and females differ in ways that dictate learning abilities. Fact: there are no meaningful distinction between boys' and girls' brains or intelligence. No research has demonstrated gender differences in how networks of neurons become connected when we learn new skills. Any structural differences are small and based on averages. In other words, they're not relevant to any given child or adult. Myth: each child has a particular learning style. Fact: the notion that a student tends to learn better by favoring a particular form of sensory input, a visual learner as opposed to one who listens better, has not received much validation in actual studies. For this and other myths, public perceptions appear to have outstripped the science. Uta Frith, a neuroscientist who chaired a British panel that looked at the promise of neuroeducation, urges parents and educators to tread cautiously. There is huge demand by the general public to have information about neuroscience for education. As a consequence, there's an enormous supply of totally untested, untried, and not very scientific methods. So as you see, we're still learning a lot about learning. On a summer day in 1968, Professor Julian Stanley met a brilliant but bored 12-year-old named Joseph Bates. The Baltimore student was so far ahead of his classmates in mathematics that his parents had arranged for him to take a computer science course at Johns Hopkins University, where Stanley taught. Even that wasn't enough. Having leapfrogged ahead of the adults in the class, the child kept himself busy by teaching the Fortran programming language to graduate students. Unsure of what to do with Bates, his computer instructor introduced him to Stanley, a researcher well known for his work in psychometrics, the study of cognitive performance. To discover more about the young prodigy's talent, Stanley gave Bates a battery of tests that included the SAT college admissions exam, usually taken by university-bound 16 to 18-year-olds in the U.S. Bates's score was well above the threshold for admission to Johns Hopkins, which prompted Stanley to search for a local high school that would let the child take advanced mathematics and science classes. When that plan failed, Stanley convinced a dean at Johns Hopkins to let Bates, who was then 13, enroll as an undergraduate. Stanley would affectionately refer to Bates as his student zero of his Study of Mathematically Precocious Youth, SMPY, which would transform how gifted children are identified and supported by the U.S. education system. As the longest-running current longitudinal survey of intellectually talented children, SMPY has for 48 years tracked the careers and accomplishments of some 5,000 individuals, many of whom have gone on to become high-achieving scientists. The study's ever-growing data set has generated more than 400 papers and several books and provided key insights into how to spot and develop talented science, technology, engineering, and mathematics, or STEM, and beyond. What Julian wanted to know was, how do you find the kids with the highest potential for excellence in what we now call STEM, and how do you boost the chance that they'll reach that potential, says Camilla P. Benbow, a protege of Stanley's, who is now Dean of Education and Human Development at Vanderbilt University. But Stanley wasn't interested in just studying bright children. He wanted to nurture their intellect and enhance the odds that they would change the world. His motto, he told his graduate students, was "No more dry bones methodology." With the first SMPY recruits now at the peak of their careers, what has become clear is how much the precociously gifted outweigh the rest of society in their influence. Many of the innovators who are advancing science, technology, and culture are those whose unique cognitive abilities were identified and supported in their early years through enrichment programs such as Johns Hopkins University's Center for Talented Youth, which Stanley began in 1979 as an adjunct to SMPY. At the start, both the study and the center were open to young adolescents who scored in the top 1% on university entrance exams. Pioneering mathematicians Terence Tao and Leonard Ng were 1%ers, as were Facebook's Mark Zuckerberg, Google co-founder Sergey Brin, and musician Stephanie Germanotta, who's better known as Lady Gaga. They all passed through the Johns Hopkins Center. Whether we like it or not, these people really do influence our society to a great degree, says Jonathan Y., Assistant Professor of Education Policy and Psychology at the University of Arkansas. Y combined data from 11 prospective and retrospective longitudinal studies, including SMPY, to demonstrate the correlation between early cognitive ability and adult achievement. The kids who test in the top 1% tend to become our eminent scientists and academics, our Fortune 500 CEOs and federal judges, our senators and billionaires and influential journalists, he says. Such results contradict long-established ideas suggesting that expert performance is built mainly through practice, that anyone can get to the top with enough focused effort of the right kind. SMPY, in contrast, suggests that early cognitive ability has more effect on achievement than either deliberate practice or environmental factors. The research emphasizes the importance of nurturing precocious children. At the same time, the work to identify and support academically talented students has raised troubling questions about the risks of labeling children and the shortfalls of talent searches and standardized tests as a means of identifying high-potential students, especially in poor and rural districts. With so much emphasis on predicting who will rise to the top, we run the risk of selling short the many kids who are missed by these tests, says Donna Matthews, a developmental psychologist in Toronto, who co-founded the Center for Gifted Studies in Education at Hunter College. Camilla Benbow was a graduate student at Johns Hopkins in 1976 when she met Stanley in a class he taught. Benbow and her husband, psychologist David Lubinsky, have co-directed the study since Stanley's retirement, and they brought it to Vanderbilt in 1998. In a sense, that brought Julian's research full circle, since this is where he started his career as a professor, Benbow says, of the university's psychology laboratory, the first U.S. building dedicated to the study of psychology. Built in 1915, it houses a small collection of antique calculators, the tools of quantitative psychology in the early 1950s when Stanley began his academic work in psychometrics and statistics. His interest in developing scientific talent had been piqued by one of the most famous longitudinal studies in psychology, Lewis Terman's Genetic Studies of Genius. Beginning in 1921, Terman selected teenage subjects on the basis of high IQ scores, then tracked and encouraged their careers. But to Terman's chagrin, his cohort produced only a few esteemed scientists. Among those rejected, because their IQ of 129 was too low to make the cut, was William Shockley, the Nobel Prize-winning co-inventor of the transistor. Physicist Luis Alvarez, another Nobel winner, was also rejected. Stanley suspected that Terman wouldn't have missed Shockley and Alvarez if he'd had a reliable way to test them specifically on quantitative reasoning ability. So Stanley decided to try the Scholastic Aptitude Test, now simply known as the SAT. Although the test is intended for older students, Stanley hypothesized that it would be well suited to measuring the analytical reasoning abilities of elite younger students. In March 1972, Stanley rounded up 450 bright 12 to 14-year-olds from the Baltimore area and gave them the mathematics portion of the SAT. It was the first standardized academic talent search. Later, the researchers included the verbal portion and other assessments. The first big surprise was how many adolescents could figure out math problems that they hadn't encountered in their coursework, says developmental psychologist Daniel Keating, then a PhD student at Johns Hopkins. The second surprise was how many of these young kids scored well above the admissions cutoff for many elite universities. Stanley hadn't envisioned SMPY as a multi-decade longitudinal study, but after the first follow-up survey 5 years later, Benbow proposed extending the study to track subjects through their lives, adding cohorts and including assessments of interests, preferences, and occupational and other life accomplishments. The study's first 4 cohorts ranged from the top 3% to the top 0.01% in their SAT scores. The SMPY team added a 5th cohort of the leading mathematics and science graduate students in 1992 to test the generalizability of the talent search model for identifying scientific potential. I don't know of any other study in the world that has given us such a comprehensive look at exactly how and why STEM talent develops, says Christoph Perleff, a psychologist at the University of Rostock in Germany, who studies intelligence and talent development. As the data flowed in, it quickly became apparent that a one-size-fits-all approach to gifted education and to education in general was inadequate. SMPY gave us the first large sample basis for the field to move away from general intelligence toward assessments of specific cognitive abilities, interests, and other factors, says Rena Subotnick, who directs the Center for Gifted Education Policy at the American Psychological Association in Washington, D.C. In 1976, Stanley started work with his second cohort, which was a sample of 563 13-year-olds who scored in the top 0.5% on the SAT. He tested them on spatial ability, the capacity to understand and remember spatial relations between objects. Tests for spatial ability might include matching objects that are seen from different perspectives, determining which cross-section will result when an object is cut in certain ways, or estimating water levels on tilted bottles of various shapes. Stanley was curious about whether spatial ability might better predict educational and occupational outcomes than could measures of quantitative or verbal reasoning on their own. Follow-up surveys at ages 18, 23, 33, and 48 backed up his hunch. A 2013 analysis found a correlation between the number of patents and peer-refereed publications that people had produced and their earlier scores on SATs and spatial ability tests. The SAT test jointly accounted for about 11% of the variance. Spatial ability accounted for an additional 7.6%. The findings, which dovetail with those of other recent studies, suggest that spatial ability plays a major part in creativity and technical innovation. I think it may be the largest known untapped source of human potential, says Lubinsky, who adds that students who are only marginally impressive in mathematics or verbal ability, but high in spatial ability, often make exceptional engineers, architects, and surgeons. And yet no admissions directors I know of are looking at this, and it's generally overlooked in school-based assessments. When Stanley began his work, the choices for bright children in the U.S. were limited. So he sought out environments in which early talent could blossom. It was clear to Julian that it's not enough to identify potential. It has to be developed in appropriate ways if you're going to keep that flame well lit, says Linda Brody, who studied with Stanley and now runs a program at Johns Hopkins focused on counseling profoundly gifted children. At first, the efforts were on a case-by-case basis. Parents of other bright children began to approach Stanley after hearing about his work with Bates, who thrived after entering the university. By age 17, he had earned bachelor's and master's degrees in computer science and was pursuing a doctorate at Cornell University. Later, as a professor at Carnegie Mellon University, he would become a pioneer in artificial intelligence. I was shy, and the social pressures of high school wouldn't have made it a good fit for me, says Bates, who's now 60. But at college, with the other science and math nerds, I fit right in, even though I was much younger. I could grow up on the social side at my own rate, and also on the intellectual side, because the faster pace kept me interested in the content. The SMPY data supported the idea of accelerating fast learners by allowing them to skip school grades. In a comparison of children who bypassed a grade with a control group of similarly smart children who didn't, the grade skippers were 60% more likely to earn doctorates or patents, and more than twice as likely to get a PhD in a STEM field. Acceleration is common in SMPY's elite 1 in 10,000 cohort, whose intellectual diversity and rapid pace of learning make them among the most challenging to educate. Advancing these students costs little or nothing, and in some cases may save schools money. These kids often don't need anything innovative or novel, Lubinsky says. They just need earlier access to what's already available to older kids. Many educators and parents continue to believe that acceleration is bad for children, that it will hurt them socially, push them out of childhood, or create knowledge gaps. But education researchers generally agree that acceleration should be much more frequently considered for kids who are advanced relative to their age peers. When carefully applied, with the necessary supports for children and their teachers, acceleration is usually beneficial socially and emotionally, as well as academically and professionally. Skipping grades is not the only option. SMPY researchers say that even modest interventions, for example, access to challenging material such as college-level advanced placement courses, have a demonstrable effect. Among students with high ability, those who were given a richer density of advanced pre-collegiate educational opportunities in STEM went on to publish more academic papers, earn more patents, and pursue higher-level careers than their equally smart peers who didn't have these opportunities. Despite SMPY's many insights, researchers still have an incomplete picture of giftedness and achievement. We don't know why, even at the high end, some people will do well and others won't, says Douglas Detterman, a psychologist who studies cognitive ability at Case Western Reserve University. Intelligence won't account for all the differences between people. Motivation, personality factors, how hard you work, and other things are important. Some insights have come from German studies that have a methodology similar to SMPY's. The Munich longitudinal study of giftedness, which started tracking 26,000 gifted students in the mid-1980s, found that cognitive factors were the most predictive, but that some personal traits, such as motivation, curiosity, and ability to cope with stress, had a limited influence on performance. Environmental factors such as family, school, and peers also had an impact. The data from such intellectual talent searches also contribute to knowledge of how people develop expertise in subjects. Some researchers and writers, notably psychologist Anders Ericsson of Florida State University and author Malcolm Gladwell, have popularized the idea of an ability threshold. This holds that for individuals beyond a certain IQ barrier, and 120 is often cited, concentrated practice time is much more important than additional intellectual abilities in acquiring expertise. But data from SMPY and the Duke Talent Program challenge that hypothesis. A study published in 2018 compared the outcomes of students in the top 1% of childhood intellectual ability with those in the top 0.01%. Whereas the first group gained advanced degrees at about 25 times the rate of the general population, the more elite students earned PhDs at about 50 times the base rate. But some of this work is controversial. In North America and Europe, some child development experts lament that much of the research on talent development is driven by the urge to predict who will rise to the top. And educators have expressed considerable unease about the concept of identifying and labeling a group of pupils as gifted or talented. A high test score tells you only that a person has high ability and is a good match for that particular test at that point in time. A low test score tells you practically nothing, Matthews says, because many factors can depress students' performance, including their cultural backgrounds and how comfortable they are with taking high-stakes tests. Matthews contends that when children who are near the high and low extremes of early achievement feel assessed in terms of future success, it can damage their motivation to learn and can contribute to what Stanford University psychologist Carol Dweck calls a fixed mindset. It's far better, Dweck says, to encourage a growth mindset in which children believe that brains and talent are merely a starting point and that abilities can be developed through hard work and continued intellectual risk-taking. Students focus on improvement instead of worrying about how smart they are and hungering for approval, Dweck says. They work hard to learn more and get smarter. Research by Dweck and her colleagues shows that students who learn with this mindset show greater motivation at school, get better marks, and have higher test scores. Benbow agrees that standardized tests should not be used to limit students' options, but rather to develop learning and teaching strategies appropriate to children's abilities, which allow students at every level to reach their potential. As Benbow and Lubinsky's work shows, gifted students can shape the future. When you look at the issues facing society, whether it's healthcare, climate change, terrorism, energy, these are the kids who have the most potential to solve these problems, Lubinsky says. These are the kids we do well to bet on. More than 30 years ago, James R. Flynn, a researcher at the University of Otago in New Zealand, made a surprising discovery that scientists are still trying to explain. IQ scores have been increasing steadily since the beginning of the 20th century. Flynn went on to examine intelligence test data from more than 24 countries and found that scores were rising by 0.3 of a point a year, 3 full points every decade. Nearly 3 decades of follow-up studies have confirmed the statistical reality of the global uptick, now known as the Flynn effect. And the scores are still climbing. To my amazement, in the 21st century, the increases are continuing, says Flynn, who published a book in 2012 called Are We Getting Smarter? The latest data show the gains in America humming right along at the old rate of 0.3 of a point a year. One of the strangest aspects of the Flynn effect is its relentless monotony. It does not slow or stop and restart. It just moves steadily upward. Joseph Rogers, a psychologist now at Vanderbilt University, examined the test results of nearly 13,000 American students to see if he could detect the Flynn effect on more granular timescales. We wondered if the students' scores would get better over a 5 or a 10-year period. Well, they got better over a 1-year period, Rogers says. The increase is there systematically, year by year by year. Kids born in 1989 do a little better than kids born in 1988. The Flynn effect means that children will, on average, score about 10 points higher on IQ tests than their parents did. By the end of this century, our descendants will have a nearly 30-point advantage over us. The difference between average intelligence and the top 2% of the population, if the Flynn effect continues. But can it continue? Will the trend go on indefinitely, leading to a future filled with people who would be considered geniuses by today's standards? Or is there some natural limit to the Flynn effect and to human intelligence? Almost as soon as researchers recognized the Flynn effect, they saw that the ascending IQ scores were the result almost entirely of improved performances on specific parts of the most widely used intelligence tests. One such test, called the Wechsler Intelligence Scale for Children, or WISC, has multiple sections, each of which assesses different skills. It would seem more natural to expect improvements in crystallized intelligence, the kind of knowledge picked up in school. But that's not what's happening. Scores in the section that measure skills in arithmetic and vocabulary levels have remained largely constant over time. Most of the IQ gains come from just two subtests devoted to abstract reasoning. One deals with similarities and poses questions such as, how are an apple and an orange alike? A low-scoring answer would be, they're both edible. A higher-scoring response would be, they're both fruit, an answer that transcends simple physical qualities. The other subtest consists of a series of geometric patterns that are related in some abstract way, and the test taker must correctly identify the relation among the patterns. A paradox of the Flynn effect is that tests such as these were designed to be completely nonverbal and culture-free measurements of what psychologists call fluid intelligence, an innate capacity to solve unfamiliar problems. Yet the Flynn effect clearly shows that something in the environment is having a marked influence on the supposedly culture-free components of intelligence in populations all the world over. Psychologists Ainsley Mitchum of Florida State University and Mark Fox, then at the University of Richmond, have made detailed studies of generational differences in performance on intelligence tests. They suspect that our enhanced ability to think abstractly may be linked to a new flexibility in the way we perceive objects in the world. Everybody is familiar with the start button on a computer screen, but it's not really a button, Mitchum says. I was trying to explain to my grandmother how to turn her computer off, and I said, well, you hit the start button and select shutdown. She was banging the mouse on the screen. Mitchum adds that his grandmother is not unintelligent. She just grew up in a world where buttons were buttons, and phones certainly were not cameras. Many researchers, Flynn among them, argue that rising IQ scores do not reflect an increase in raw brain power. Rather, the Flynn effect shows how modern our brains have become. Such tests require a facility with recognizing abstract categories and making connections among them. And that facility, Flynn says, has become more useful over the past century than at any previous time in human history. If you don't classify abstractions, if you're not used to using logic, you can't really master the modern world, Flynn says. Alexander Luria, a Soviet psychologist, did some wonderful interviews with peasants in rural Russia in the 1920s. He would say to them, where there is always snow, bears are always white. There is always snow at the North Pole. What color are the bears there? They would say they had never seen anything but brown bears. They didn't think of a hypothetical question as meaningful. The peasants were not stupid. Their world just required different skills. I think the most fascinating aspect of this isn't that we do so much better on IQ tests, Flynn says. It's the new light it sheds on what I call the history of the mind in the 20th century. A naive interpretation of the Flynn effect quickly leads to some strange conclusions. Simply extrapolating the effect back in time, for example, would suggest that the average person in Great Britain in 1900 would have had an IQ of around 70 by 1990 standards. That would mean that the average Brit wouldn't have been able to follow the rules of cricket, says David Hambrick, a cognitive psychologist at Michigan State University. And of course, that's absurd. We may not be smarter than our ancestors, but there is no doubt our minds have changed. Flynn believes the change began with the Industrial Revolution, which engendered mass education, smaller families, and a society in which technical and managerial jobs replaced agricultural ones. New professional classes emerged: engineers, electricians, industrial architects, and their positions demanded a mastery of abstract principles. Education, in turn, became the driver for still more innovation and social change, setting up an ongoing positive feedback loop. Most researchers agree with Flynn's broad assessment that the Industrial Revolution and technological advances are responsible for his eponymous effect. Yet pinning down precise causes, which might allow for the design of educational or social policies to augment the effect, has been difficult. Improvements in education certainly account for part of the advances. As recently as the beginning of the 20th century, most Americans spent no more than 7 years in school. Today, about half of all adults have had some form of tertiary education. Formal education, though, cannot entirely explain what is going on. Some researchers had assumed that most of the IQ increases seen in the 20th century might have been driven by gains at the left end of the intelligence bell curve among those with the lowest scores, an outcome that would likely be a consequence of better educational opportunities. A 2011 study by Jonathan Y., now at the University of Arkansas, and Martha Putalas of Duke University, however, looked at 20 years of data that comprised 1.7 million test results of 5th, 6th, and 7th graders, and found that the scores of the top 5% of the students were going up in perfect lockstep with the Flynn effect. Y and Putalas' results suggest that because the entire intelligence curve is shifting, the cultural forces behind the increase must be influencing everyone equally. The researchers speculate that the ubiquity of sophisticated video games and even some television shows may provide a training ground that enhances the problem-solving skills needed for IQ tests. For Rogers, the universality of the Flynn effect confirms the pointlessness of seeking a single cause. There must be 4 or 5 dominant causes, any one of which can stand against fluxes or wanes in the other. Improved childhood nutrition, universal education, and smaller families are some of the most likely causes. In a 2017 study, Rogers and graduate student Patrick O'Keefe identified the role of highly educated mothers as another potentially important factor. As long as 2 causes were in existence, even when something like the Second World War came along and caused the other 2 to disappear, the Flynn effect kept cranking along, Rogers says. Will IQ scores keep going up? One thing we can be sure of is that the world around us will continue to change. Flynn likes to use a technological analogy to describe the long-term interaction between mind and culture. The speeds of automobiles in 1900 were absurdly slow because the roads were so lousy, he says. You would have shaken yourself to pieces. But roads and cars co-evolved. When roads improved, cars did too, and improved roads prompted engineers to design even faster cars. Our minds and culture are locked in a similar feedback loop. We are creating a world where information takes forms and moves with speeds unimaginable just a few decades ago. Every gain in technology demands minds capable of accommodating the change, and the changed mind reshapes the world even more. The Flynn effect is unlikely to end during this century, presaging a future world where you and I would be considered woefully pre-modern and literal. Of course, our minds are not only changing in ways that can be captured by IQ tests. People are getting faster. I'm certain of this, Hambrick says. A common practice in reaction time research is to discard responses that are below about 200 milliseconds. It had been thought that 200 milliseconds is about the fastest that people can respond. But if you ask someone who has done this sort of research, they're having to discard more trials. People are getting faster. We text, we play video games, we do a lot more things that require really fast responses. I think once we have enough data, we'll be able to see a Flynn-like effect on measures of perceptual speed. Maybe we should not be so surprised by the existence of something like the Flynn effect. Its absence would be more startling. It would mean we were no longer responding to the world we are creating. The Flynn effect itself is neither good nor bad. It is a symptom of our adaptability. If we're lucky, perhaps we will keep building a world that will make us smarter and smarter, one where future generations will marvel at our simplicity. What if you could pop a pill that made you smarter? It sounds like a Hollywood movie plot, but people have been searching for ways to boost their brain power, perhaps for all of history. In the past century, scientific efforts have revealed a few promising chemicals, including the following. Caffeine. It's one of the oldest and most popular stimulants. People recognized caffeine's stimulant properties hundreds, perhaps thousands of years ago. It can enhance alertness and attention. However, the effects are short-lived and tolerance builds up quickly. Nicotine. It's also a stimulant. It's been used for hundreds of years for a range of medicinal purposes. It is very addictive and it has many dangerous side effects. Amphetamine, such as Benzedrine or Adderall. First synthesized in 1887, Benzedrine was the first drug to treat hyperactivity in children. Amphetamine can enhance attention and memory by increasing levels of norepinephrine and dopamine in the brain. But the compound can be addictive, and it comes with a range of side effects, including appetite loss, disturbed sleep, and even psychosis. Methylphenidate, or Ritalin, first marketed in 1954 and prescribed in the 1960s for treating hyperactivity. It became popular for attention deficit hyperactivity disorder, or ADHD, in the 1990s. As with amphetamine, it can improve memory and focus for those with ADHD, but it is also used off-label as a study and work aid. Some people build up a tolerance to Ritalin over time. Acetylcholinesterase inhibitor, or Aricept. Approved to treat Alzheimer's disease in the 1990s, it has been shown in sub-studies to enhance memory and attention in healthy people. More recently, researchers have found that a drug called modafinil boosts higher-order cognitive function without causing serious side effects. One recent review of 19 placebo-controlled trials found that the drug had a small but reliable effect on cognition. Modafinil has been prescribed in the U.S. since 1998 to treat sleep-related conditions such as narcolepsy and sleep apnea, and it heightens alertness much as caffeine does. Another review found that the methods used to evaluate modafinil affected the outcomes. So research that looked at the drug's effects on the performance of simple tasks, such as pressing a particular button after seeing a certain color, did not detect many benefits. Yet studies that asked participants to do complex and difficult tasks after taking modafinil or a placebo found that those who took the drug were more accurate, which suggests that it may affect higher cognitive functions, mainly executive functions, but also attention and learning, explains study co-author Ruode Battleday, now a medical doctor and PhD student at the University of California, Berkeley. Trials have not yet been done on modafinil's long-term effectiveness or safety. Studies of the drug have been carried out in a controlled scientific environment and usually only looked at the effects of a single dose, explains neuropsychologist and review co-author Anna Catherine Brem, then at Oxford. So no one yet knows whether it is safe for long-term use in healthy people. Nor is it known whether modafinil might lose its edge with repeated use, which is a phenomenon familiar to many coffee drinkers. Side effects are another important consideration. Modafinil has been shown to cause insomnia, headache, and stomach ache in some users, and some research suggests that it could be addictive. Although these kinds of problems may be worth enduring for a drug that treats an illness, if you don't have a medical condition, the risks versus benefits change dramatically, says Sharon Morin-Zamir, a psychologist at the University of Cambridge, who studies ethical considerations associated with the use of cognition-enhancing drugs. For some, the benefits will likely outweigh risks, at least some of the time, she says. Whereas for others, this may not be the case. A pill you take to ace an exam, for instance, won't do you much good if it also causes a grueling stomach ache. And when it comes to children and teens, cognition-enhancing drugs could present unique risks to the developing brain. Several clinical trials found modafinil to be safe when given to children with ADHD, but the trials lasted only a few months, making it difficult to ascertain the potential effects of long-term use. In a 2014 article examining the biochemical effects of modafinil and other common smart drugs, researchers at the University of Delaware and Drexel University raised concerns that the use of these drugs could affect the developing brain's ability to adapt to new situations and might increase the risk for addictive behaviors. Some engineers and hobbyists have turned to a different kind of potential brain booster, a jury-rigged electric technology that purportedly enhances brain function. This form of attempted brain hacking, known as transcranial direct current stimulation, or TDCS, is not as far-fetched as it might sound. The brain runs on electricity. Brain cells build up charges that impel chemical signals across synapses, the tiny gaps between neurons. When we learn something, the synapses involved become conditioned to fire more readily, and TDCS supposedly enhances that process. The tiny electric currents TDCS uses, which are generally 1 to 2 milliamps, cannot actually trigger the chemical impulse that crosses a synapse, but some researchers believe TDCS strengthens synaptic connections to make learning more efficient. Small laboratory studies suggest it can improve vigilance and reaction times. You get more bang for your buck by combining TDCS with conventional training, contends Maram Bixen, a professor of biomedical engineering at the City College of New York. The dawn of the non-invasive brain stimulation movement is widely attributed to a 2000 paper by German neurophysiologists Michael Nitsche and Walter Paulus. In a small study of healthy 20-somethings, the scientists showed they could make neurons more or less excitable by sending weak electric currents through the brain's motor cortex. The effects lingered minutes after stimulation. Previously, TDCS had only been studied in animals. A subsequent study in 2003 showed that such stimulation could improve a cognitive ability psychologists call motor sequence learning, the process of training to perform a series of precise steps. Several labs at Harvard Medical School and the National Institutes of Health picked up on these findings and conducted research suggesting TDCS had a potential for stroke rehabilitation and chronic pain. Brett Wingeier began watching the field in 2006. He was the principal biomedical engineer at NeuroPace, a Silicon Valley company that manufactures brain implants intended to help control epilepsy. He had also worked on brain stimulators for alleviating cluster headaches and some symptoms of Parkinson's disease. Some patients can be incapacitated, but you turn the stimulator on and it all goes away. It's amazing, Wingeier says. Yet he notes that those devices are only relevant to patients with relatively severe disorders. They're surgical implants. Wingeier dreamed of using neurotechnology to help more patients and maybe even healthy people. He was excited to see new TDCS studies, but many were done with yellow sponges and measuring tape and straps on your head, he says. The time seemed ripe to consider bringing product design principles into what he calls a legitimate consumer product people can pull out of the box and use. More plans began taking shape as scientists fleshed out possible mechanisms for how TDCS works. In a set of electrophysiology experiments published in 2009, Bixen and some of his colleagues demonstrated that a mild electric field can synchronize activity in a neural network. Such insights inspired Wingeier and other researchers working to target TDCS to specific brain areas. Some studies suggest brain stimulation might help people with neuropathic pain, as well as depression, schizophrenia, or people recovering from a stroke. For now, TDCS remains investigational for medical uses in the US, although in Europe, such devices are approved for treating pain and depression. More than 600 TDCS studies are listed in the clinicaltrials.gov database that tracks ongoing trials for drug therapies or medical devices. In addition, a growing number of studies are testing TDCS in healthy people, and suggest it can improve working memory, attention, and decision-making, as well as stimulate creativity. A 2012 study funded by the U.S. Department of Defense indicated TDCS may heighten vigilance, making people faster at spotting bombs, snipers, and other threats in fuzzy images. 4 other labs have since shown the technology could enhance learning. One of the few TDCS effects that's been replicated across institutions, says Vincent Clark, a cognitive neuroscientist who directs the Psychological Clinical Neuroscience Center at the University of New Mexico. The academic literature on TDCS has spurred a wave of media articles claiming that jolts to the brain can improve memory, boost math skills, and bring out the genius in you. An article in the Journal of Medical Ethics calls TDCS the Swiss Army knife of human neuroscience. As word of TDCS's potential reaches the general public, home users have been convening in cyberspace. In 2011, TDCS users created a Reddit forum and launched a blog the following year. Thousands of home users visit these websites to discuss scientific papers, post how-to videos, and ask questions such as where to place electrodes and how long to stimulate. In 2013, the first consumer TDCS wearable, a headset for gamers, appeared on the market. Since then, more than a dozen companies have started selling TDCS products. Most consumer TDCS devices are not marketed for clinical purposes, but for leisure and cognitive enhancement. None of the consumer kits have officially undergone the rigorous testing process that a drug or medical device must undergo for approval by the Food and Drug Administration. And the purchaser has only the manufacturer's claim that it works for its intended use. And intended uses can be ambiguous. For example, when companies assert their TDCS device increases concentration or amps up brain function, it is hard to determine if such instruments fall under the FDA's purview, says Anna Wexler, a postdoctoral student at the University of Pennsylvania, who studies the ethical, legal, and social implications of neurotechnology. The agency defines a medical device as an instrument that is intended to affect the structure or any function of the body, she says. The way a manufacturer markets the product determines the regulatory pathway, adds Wexler, who explored some of these issues in a 2015 paper in Journal of Medical Ethics. Enhancement claims have aroused suspicion among scientists, prompting more controlled lab studies. In one experiment, published in 2016, a team from the Netherlands reported that a commercial TDCS headset actually made participants less accurate in a well-established test of working memory. A major problem with assessing how well the technology works is that the vast majority of research studies use brain stimulation for different purposes than do home TDCS users. Contrast home usage with the 2000 paper authored by Nietzsche and his colleagues that tested whether non-invasive brain stimulation could help people recover movement after a stroke. We just wanted to know if we could change motor performance, Nietzsche says. Our question was not, does the stimulation protocol induce maximal performance? Home TDCS users, on the other hand, are not particularly interested in making new scientific discoveries, Wexler says. They're interested in self-improvement. This quest for enhancement could potentially lead to untoward consequences. In 2016, clinicians and scientists who study TDCS published an Annals of Neurology editorial warning of potential undesired effects. For example, stimulating one brain area might help someone learn new material, but hurt the ability to process learned material. Changes in brain activity might last longer than users expect, or may extend beyond the regions underneath the electrodes. Also, the effects of TDCS vary tremendously across individuals and with small changes in the process. When it comes to placing electrodes, even just a few centimeters can be enough to change the effect, Clark says. How long you stimulate, how much current you put in, if it's 2 or 1 milliamp or something in between, all of that matters. Genetics, age, and skull thickness also seem to influence the response. The technical specifications for medical uses have yet to be clearly delineated, let alone the parameters for cognitive enhancement. In addition to applying direct current to the scalp, brain hacking researchers and DIYers are experimenting with other methods, including alternating current and random noise stimulation. These might one day complement more established non-invasive medical technologies, such as magnetic stimulation and ultrasound, to influence brain function and behavior. Transcranial direct current stimulation, Clark says, is just the tip of the iceberg. Leaving aside methods of artificial stimulation, cases of so-called accidental genius have proved intriguing to researchers. A 10-year-old boy, Orlando Serrell, knocked unconscious one day by a baseball, discovered afterward that he could bring to mind the exact day of the week for any date after the accident and could remember the weather for each day since the trauma as well. He could also recall the most minute daily events. Jason Paget, the victim of a brutal mugging in 2002 that left him with a severe concussion, soon afterward began to see what he described simply as images. He began to sketch them out on paper. When he showed his work to others, he learned that the repeating, self-similar patterns were fractals. These two people have a remarkable condition known as acquired savant syndrome. In the more familiar form of savantism, made famous by the 1988 movie Rain Man, people are endowed from early in life with extraordinary but narrowly defined musical, artistic, mathematical, memory, and mechanical skills that stand in contrast to impairments in language, social interactions, and other mental faculties. In Rain Man, for instance, actor Dustin Hoffman's character, Raymond Babbitt, has stunning mathematical, calendar calculating, and other skills, and a massive memory, but also shows severe cognitive and behavioral limitations. In acquired savant syndrome, in contrast, extreme artistic or intellectual skills show up after dementia, a severe blow to the head, or another insult to the brain. Discovery of this unusual phenomenon raises the possibility that dormant potential in some artistic or intellectual realm, an inner savant, resides in each of us. If so, perhaps a way can be found to tap these buried abilities in the absence of disease or injury. Daryl A. Treffert compiled a worldwide registry of known savants. As of 2018, there are 91 recorded cases of acquired savantism. What sparked Treffert's interest in the acquired variety was attending the premiere exhibition of exceptional sculptures made by Alonzo Clemens. As an infant, Clemens seemed to learn quickly. At about age 3, however, a fall resulted in a brain injury, slowing his cognitive development precipitously and leaving him with serious intellectual disability, including limited vocabulary and speech. But afterward, he developed a spectacular skill for sculpting, using whatever materials were handy, even shortening from the kitchen. With his new talent came a growing fascination with animals. For example, he could look at a photograph of a horse in a magazine and then sculpt a three-dimensional replica in less than half an hour, each muscle and tendon reproduced in exacting detail. In 1923, psychologist Blanche M. Minogue described the appearance of extraordinary musical abilities in a 3-year-old following a bout of meningitis. In 1980, T.L. Brink, another psychologist, reported on a 9-year-old boy in whom superior mechanical skills appeared after a bullet wound to his left brain. In his case, he was able to dismantle, reassemble, and modify multi-gear bicycles and invented a punching bag that could simulate the bobbing and weaving of a live opponent. These sparse reports in the years before 1980 reflected the condition's rarity. A concussion or stroke does not usually enhance cognitive or creative capacity. Among the reports entered in Treffert's registry was work done by neurologist Bruce Miller, now at the University of California, San Francisco, and his colleagues. In 1996, Miller began compiling cases of people who had a disorder known as frontotemporal dementia, or FTD, and who demonstrated musical or artistic skills for the first time after their diagnosis. Frontotemporal dementia differs from Alzheimer's dementia in that the degenerative process affects only the frontal lobes and not wider areas of the brain. FTD often targets the left anterior temporal area of the brain and the orbitofrontal cortex. Both regions normally inhibit activity in the visual system at the back of the brain, which is involved in processing incoming signals from the eyes. The disease seems to foster a newfound artistic sensibility by turning off inhibitory signals from the front of the brain. The releasing of the brakes allows the brain to process sight and sound in new ways. It unleashes artistic or other creative sensibilities, even though damage to the frontal lobes may lead to inappropriate behaviors that characterize the disorder. FTD is an unexpected window into the artistic process, Miller says. Further work implies that accidental genius results from diminished activity in some brain areas that is combined with a counterbalancing intensification in others. More specifically, it involves a set of events that Treffert calls the 3 R's that occur after the brain is damaged. Most often after the left hemisphere is stricken, similar to what happened with Miller's FTD cases. The process begins with recruitment, a rise in electrical activity in the still intact cortical tissue, often in the right hemisphere. Then the brain circuitry undergoes rewiring to establish newly formed connections between regions that were not previously linked. Next comes release of dormant capacity as a result of increased access to the newly connected brain areas. An experiment done by Richard Chi and Alan Snyder, both then at the Center for the Mind at the University of Sydney, has used a relatively new technology to provide some evidence that these brain changes account for the acquired savant skills. Using transcranial direct current stimulation, TDCS, these researchers induced savant-like abilities in human volunteers. The technique generates a polarized electrical current to diminish activity in part of the left hemisphere involved with sensory input, memory, language, and other brain processes, while increasing activity in the right hemisphere, specifically the right anterior temporal lobe. The investigators then asked study participants to solve a challenging 9-dot puzzle, either with or without TDCS, a task that requires the creativity to search for a solution in an unconventional way. Participants had to connect 3 rows of 3 dots using 4 straight lines without lifting a pen or retracing lines. None of them could solve it before stimulation, and when 29 subjects were exposed to sham stimulation, so electrodes were placed on the scalp without any current to test for placebo effects, they were still at a loss. With the current switched on, however, about 40%, 14 of 33 participants, worked their way through the puzzle successfully. How can a person suddenly perform so much better at the flip of a switch? Because these instant savants, and congenital and acquired savants as well, know things they were never taught. Clemens, the sculptor, had no formal training in art, but he knew instinctively how to produce an armature, the frame for the sculpture, to enable his pieces to show horses in motion. One plausible explanation for the hidden talents that emerge in savant syndrome, whether early in life or induced by injury, is that these reservoirs of skill and knowledge must be inherited in some way. We do not start life with a blank slate that subsequently gets inscribed through education and other life experiences. The brain may come loaded with a set of innate predispositions for processing what it sees or for understanding the rules of music, art, or mathematics. Savants can tap into that inherited knowledge far better than the average person can. Knowing that these talents can emerge even later in life raises the question of whether everyone has the capacity to become a savant, and whether it might be possible to do so without facing the travails of brain injury or dementia. Another way to unleash buried brilliance would be to apply TDCS, or a related technology called repetitive transcranial magnetic stimulation, as a form of thinking cap that would toggle brain regions on and off to potentially augment a person's creative capacity. When a coil placed over the left temple delivers a pulsed magnetic field through the skull, the field apparently turns off brain circuits in the left temporal area that process words and other information. Right brain circuits dedicated to spatial tasks then take on a more expansive role in mental processing. In some cases, subjects exposed to the magnetic fields were better able to guess the quantity of a large collection of objects. A technological solution may not be an absolute prerequisite, however. Meditation or simple adherence to assiduous practice of an artistic skill may suffice to allow us to switch on the more creative aspects of the brain and thus explore undiscovered artistic capabilities. As investigators understand the brain better, they may find other ways of determining what happens when brain circuits are turned up or down. Diffusion tensor imaging, or DTI, and diffusion tensor tracking, or DTT, pinpoint connections among neurons, also called fiber tracking. They're better suited than earlier methods for revealing the intricacies of the wiring inside a person's head, enabling researchers to correlate brain activity to the sudden appearance of skills. These more precise technologies can provide three-dimensional images of the fibers that tie together brain cells. One challenge to uncovering the neurobiology underlying savantism has been the difficulty of observing brains as people carry out creative tasks that require movement. Not only is it hard to sculpt or play a piano inside an MRI machine, but any movement compromises the image clarity. But a newer technique, near-infrared spectroscopy, or NIRS, would sidestep such problems by replacing bulky machines with a comfortable skull cap that measures the amount of oxygen and blood flowing through the brain's blood vessels and relays the information to image processing software. Even more promising is a recently developed helmet that uses another imaging method called positron emission tomography, or PET, for monitoring when a person is sitting, standing, or even exercising. Such studies are worth pursuing. Acquired savantism provides strong evidence that a deep well of brain potential resides within us all. The challenge now is to find the best ways to tap into our inner savant while keeping the rest of our mental faculties intact. In the 1980s, philosophers would sometimes speak of the beam, a metaphorical spotlight of intellectual brilliance that could illuminate even the most complex philosophical conundrums. Only some lucky philosophers were ever born with the beam, and their work represented the gold standard of the field. Anyone who lacked the beam was forever condemned to trail behind them intellectually. Sarah Jane Leslie would share this sort of story with André Simpian whenever they would see each other at conferences. The two were trained in different disciplines, Leslie in philosophy and Simpian in psychology, but they studied similar topics, so they would get together regularly to catch up on research and talk about their experiences as members of their respective fields. Psychology and philosophy are quite similar in their substance, and in fact, psychology was a branch of philosophy until the mid-1800s. But the stories they told painted a picture of two fields with vastly different views on what is important for success. Much more so than psychologists, philosophers value a certain kind of person, the brilliant superstar with an exceptional mind. Psychologists, in contrast, are relatively more likely to believe that the leading lights in their field grew to achieve their positions through hard work and experience. At first, philosophy's obsession with brilliance appeared to be a quirk, a little strange but innocuous. Other things seemed like bigger problems in Leslie's field, such as its inability to attract women and minorities. Despite sustained attention to issues of underrepresentation, In recent years, and in some efforts to alleviate them, women still accounted for fewer than 30% of the doctoral degrees granted in philosophy in 2015. Only 1% of philosophy PhDs were Black. The field of psychology, on the other hand, has been quite successful in attracting and retaining women who earned 72% of PhDs, and Black scholars earned 6% of its 2015 doctoral degrees. The discrepancy was jarring. These two fields have so much in common. Both philosophers and psychologists ask questions about how people perceive and understand the world, how they decide between right and wrong, how they learn and use language, and so on. Even the few salient differences, such as psychologists' greater use of statistics and randomized experiments, are becoming blurred nowadays with the huge increase in the popularity of experimental philosophy, in which philosophers conduct surveys and experiments to explore different perspectives on morality, for example. How could two such closely related fields be so vastly different in membership? A eureka moment came several years ago for Leslie and Simpian when they connected two threads running through the anecdotes they had been sharing. During dinner with a group of philosophers and psychologists at a conference, the conversation happened to turn, in quick succession, from philosophers' infatuation with brilliance to the gender gap in their field. This chance juxtaposition brought to mind for Leslie and Simpian a connection they had never considered before. Maybe the premium philosophers place on brilliance is actually the reason why so few of their colleagues are women or minorities. They did not discount the benefits of brilliance. Rather, they wondered whether genius was more easily overlooked in women and Black people. Insisting on a keen intellect in a particular field could be tantamount to hanging a keep out sign to discourage any newcomers. On the surface, an emphasis on brilliance does not favor one group or another. Cognitive ability is not tied to gender or race. Philosophers seek a certain kind of mind, regardless of whose mind it is. The seemingly logical preference quickly becomes problematic, however, in light of certain shared societal notions that incorrectly associate superior intellect with some groups, usually white men, more than others. Even among the academics present that night, one of the views expressed was that men and women just thought differently. Women were alleged to be more practical and anchored in reality, whereas men were more willing to engage in the kind of counterfactual, abstract reasoning that is viewed as a sign of philosophical brilliance. It seemed possible that such stereotypes, which amount to equating brilliance with men, might well dissuade women from entering a field that holds this quality in high esteem. Moreover, current members of such a field might themselves hold different expectations about the prospects of men and women and might evaluate and encourage them differently as a result. The same logic extends to race. The United States has a long history of portraying Black people as intellectually inferior, which is particularly likely to affect participation in a field that focuses so single-mindedly on the quality of one's intellect. Considering these stereotyped and inaccurate attitudes, philosophy's fascination with brilliance may reduce its diversity. Leslie and Simpian speculated about whether the implications of this insight might extend beyond their home disciplines. Talk of brilliance is common in academia, and, they observed, quite common in fields that have similar issues with diversity, such as science, technology, engineering, or mathematics. They wondered if their anecdotal comparison of philosophy and psychology might have something new to say about the underrepresentation of women and minorities in these disciplines. The more they thought about it, the more they realized that their brilliance hypothesis might also explain some of the variability in gender and race gaps among different scientific fields. For example, women make up nearly 50% of doctoral degrees in biochemistry, but just more than 30% of PhDs in organic chemistry. The difference cannot easily be explained by the content of these fields, which overlap considerably, or by their history. Biochemistry emerged from organic chemistry at about the same time psychology separated out of philosophy as an independent discipline. They wondered whether the demographic differences between such sibling subjects, as well as more generally among scientific fields, could be explained in part by the extent to which they emphasize exceptional intellectual talent as key to success. Their hunches quickly reminded them of the rich body of work developed by psychologist Carol Dweck of Stanford University. Dweck and her colleagues have shown that one's beliefs about ability matter greatly for one's ultimate success. A person who sees talent as a stable trait, or who has a fixed mindset in Dweck's terminology, is motivated to show off this aptitude and avoid mistakes, which presumably reflect the limits of that gift. In contrast, people who adopt a growth mindset see their current capacity as a work in progress. In other words, ability is a malleable quantity that can usually be increased with more effort and better strategies. For a person with a growth mindset, mistakes are not an indictment, but rather a valuable signal highlighting which of their skills need work. As Dweck has written, students with a growth mindset are not as worried about looking intelligent, and so they take on more challenges, persist longer, and are more resilient in the face of setbacks. In contrast, those with a fixed mindset tend to see challenges as risky and effort and setbacks as signs of limited talent. Although Dweck initially studied mindsets in individuals, she and Mary Murphy, now at Indiana University Bloomington, recently suggested that organized groups of people, such as companies and clubs, may also hold these sorts of views. Their research showed that people who worked for growth mindset businesses felt far more empowered by their company and committed to it. They said that their organization valued innovation and creativity much more so than those who worked for fixed mindset companies, and that it would support them if they took a reasonable risk that did not work out. They also found that the managers in growth mindset companies more frequently said that their employees showed the potential to rise and become stars, compared with managers in fixed mindset companies. Ironically, the fixed mindset companies, for all their emphasis on talent, were not seeing as much potential in their workers. Leslie and Simpian considered whether such views might permeate entire academic disciplines as well. The fascination with brilliance in philosophy and other areas could conceivably create an atmosphere in which displays of intellectual prowess are rewarded and imperfections are to be avoided at all costs. In combination with the stereotypes suggesting that genius is concentrated in certain groups, such a perspective could easily turn toxic for members of stereotyped groups. After all, it is easy to see imperfections and inadequacies in those people who you expect to have them. Leslie and Simpian decided to contact academic professionals from across a wide range of disciplines and ask them whether they thought that some form of exceptional intellectual talent was necessary for success in their field. They then looked up statistics on the gender and racial and ethnic composition of the people obtaining PhDs in those disciplines, which the National Science Foundation supplies on its website. Their hunch was that disciplines that place more value on brilliance would tend to have fewer female and Black PhDs. This pattern should hold not just at the macro level, when comparing the hard sciences, for example, with the social sciences and humanities, but also within these broad domains, for disciplines as similar as philosophy and psychology. More than a year and thousands of emailed surveys later, they and their collaborators, Meredith Meyer of Otterbein University in Ohio and Edward Friedland of Princeton University, finally had an answer to some of their questions. The responses received from almost 2,000 academics across 30 fields matched the distribution of PhDs in the way that they had expected. Fields that placed more value on brilliance also conferred fewer PhDs on women and Black scholars. The greater the emphasis on the single fixed trait, the fewer doctoral degrees were awarded to either of these groups. The proportion of female and Black PhDs in psychology, for example, was higher than the proportions for philosophy, math, or physics. Next, the researchers separated the responses in the physical and biological sciences from those in the humanities and social sciences. Analyses of these subgroups indicated that a stronger emphasis on brilliance correlated with fewer female and Black PhDs, regardless of whether we compared physics with biology or philosophy with sociology. It seemed that the team had stumbled onto an explanation that was general enough to describe the representation of multiple stereotyped groups in fields across the entire academic spectrum. All they had really shown at this point, however, was a correlation between the presumed desirability of a fixed trait, brilliance, with the dearth of women or Black people in a given field. They had not yet demonstrated cause and effect. Certainly, many other plausible explanations for the gender imbalances have been proffered over the years, from a heavier workload that favored single men and those with wives who did not work outside the home, to a supposed female preference for working with living organisms as opposed to inanimate objects. The team carefully examined the most common alternatives. For instance, did their brilliance measure simply track differences between fields in their reliance on math? They looked at the math portion of incoming students' graduate record examinations, or GREs, as a proxy. Beliefs about brilliance still predicted women's representation above and beyond those scores. Similarly, they found no support for the common view that women are underrepresented in high-powered fields because they prefer a better work-family balance. The team asked the academics in their sample how many hours they worked per week, both on and off campus. Taking into account these differences in workload did not, however, reduce the explanatory power of beliefs about brilliance. This single variable still predicted the magnitude of gender gaps across the 30 disciplines. The team also considered the prevalent thought that women might be more interested in working with and have a better intuitive understanding of people, whereas men prefer inanimate systems. But an analysis of the many branches of philosophy, for example, that do in fact consider people and are still dominated by men basically blew up that idea. As often happens in research, this initial study made it clear how much was not yet known about the phenomenon being investigated. For example, it would be important to know if academics' beliefs about brilliance predict gender and race gaps at earlier points in students' educational trajectories. The team was very interested in testing their idea at the bachelor's level, which is the gateway to students' later academic careers. Do field-level messages about the importance of brilliance relate to the majors that female and Black students pursue? The answer to this question is yes, as they found when they analyzed anonymous student evaluations of their college instructors on ratemyprofessors.com. The team found that undergraduates were nearly twice as likely to describe male professors as brilliant or a genius compared with female professors. In contrast, they used terms such as excellent or amazing equally often for men and women on the popular website. Leslie and Simpian determined that the overall amount of talk about brilliance and genius in the student reviews, which is a proxy for the field's emphasis on those qualities, correlated closely with a lack of diversity in completed majors. Further research showed that non-academics share similar notions of which fields require brilliance. Exposure to these ideas at home or school could discourage young members of stereotyped groups from pursuing certain careers before they even set foot on a college campus. At this point, the team needed to investigate the development of these stereotypes. When do young people in our culture start thinking that some groups have more brilliant people in them? It could be that this stereotype emerges late in development after sustained exposure to relevant cultural input. For example, media portrayals of brilliance and gender-biased expectations from parents and teachers, professors, and peers. But evidence from developmental psychology suggests that children are cultural sponges. They're incredibly sensitive to signals in their social environments. In fact, youngsters in early elementary grades seem to have already absorbed the stereotypes that associate math with boys and reading with girls. From this perspective, we might expect that stereotypes about brilliance would also be acquired early in life. To explore this idea, the team asked hundreds of 5-, 6-, and 7-year-old children questions that measured whether they associated being really, really smart, which was the researchers' child-friendly translation of brilliant, with their own gender. The results were consistent with the literature on the early acquisition of gender stereotypes, yet were still shocking to them. At 5 years old, boys and girls showed no difference in their self-assessment. But by age 6, girls were less likely than boys to think that members of their gender are really, really smart. The researchers then asked whether these stereotypes might already begin to constrain boys and girls' interests at such a young age. They introduced another group of 5, 6, and 7-year-olds to unfamiliar game-like activities that the researchers described as being for children who are really, really smart. They then compared boys' and girls' interest in those activities at each age. The results revealed no gender differences at age 5, but significantly greater interest from boys at 6 and 7 years of age, which is exactly where they saw the stereotypes emerge. In addition, the children's own stereotypes directly predicted their interest in these novel activities. The more a child associated brilliance with the opposite gender, the less interested he or she was in playing games for really, really smart children. This evidence suggests an early link between stereotypes about brilliance and children's aspirations. Over the rest of childhood development, this link may funnel many capable girls away from disciplines that our society perceives as being primarily for brilliant people. The hard work of figuring out how best to put all this information to use, how to intervene, lies ahead. But a few suggestions follow pretty directly from the evidence we have so far. Minimizing talk of genius or brilliance with students and protégés may be a relatively easy and effective way of making one's field more welcoming for members of groups that are negatively stereotyped in this respect. Given current societal stereotypes, messages that portray this trait as singularly necessary may needlessly discourage talented members of stereotyped groups. The changes may need to go deeper than talk, however, and tackle some of the entrenched systemic issues that encourage a field's fascination with brilliance. Refraining from mentioning the beam will not help young women in philosophy if the rest of the field's practices continue to be anchored in the idea that brilliance is all that matters. Another key takeaway is that we may need to intervene earlier than conventional wisdom suggests. Developmental data indicate that some of the psychological processes that work against diversity can be traced all the way back to elementary school and even before. In 2013, Carol Dweck and colleagues at Stanford and the University of Chicago examined how mothers praise their babies, analyzing videotaped interactions when the children were 1, 2, and 3 years old. 5 years later, when the children were in second grade, Dweck and her team assessed their mindset and appetite for challenge. They discovered that the mother's earlier pattern of praise predicted their children's mindset and their desire for challenge in second grade. The mothers who gave their children more process praise, focused on actions, persistence, or strategies relative to other forms of praise, raised kids with stronger growth mindsets and more interested in tackling challenges. In a follow-up study, Dweck found that this latter group of children continued to progress and showed higher math and verbal achievement 2 years later in fourth grade. Waiting until college to step in and ensure that all young people have a fair shot at finding the careers that might suit them no longer seems like the best timed intervention. We as a society would be wise to encourage a growth perspective as opposed to a fixed trait mindset starting in young children as well. There's another factor at play here, the question of whether intelligence alone is really the most valuable quality one can bring to a field in the first place. We all probably know someone who is intelligent but does surprisingly stupid things. As Heather A. Butler of California State University, Dominguez Hills admits, "My family delights in pointing out times when I, a professor, make really dumb mistakes." What does it mean to be smart or intelligent? Our everyday use of the term is meant to describe someone who is knowledgeable and makes good decisions. But the most widely known measure of intelligence, the IQ test, quantifies very different skills using visuospatial puzzles, math problems, pattern recognition, vocabulary questions, and visual searches. The advantages of being intelligent, as measured by an IQ test, are undeniable. Intelligent people are more likely to get better grades and go farther in school. They are more likely to be successful at work, and they are less likely to get into trouble, for example, by committing crimes, as adolescents. Given all the advantages of intelligence, though, you may be surprised to learn that it does not predict other life outcomes, such as well-being. You might imagine that doing well in school or at work might lead to greater life satisfaction, but several large-scale studies have failed to find evidence that IQ affects happiness or longevity. University of Waterloo psychologist Igor Grossman and his colleagues argue that most intelligence tests fail to capture real-world decision-making and our ability to interact well with others. This is, in other words, perhaps why smart people do dumb things. The ability to think critically, on the other hand, has been associated with wellness and longevity. Critical thinking is a collection of cognitive skills that allow us to think rationally in a goal-oriented fashion and a disposition to use those skills when appropriate. Critical thinkers are amiable skeptics. They are flexible thinkers who require evidence to support their beliefs and recognize fallacious attempts to persuade them. Critical thinking means overcoming all kinds of cognitive biases, for instance, hindsight bias or confirmation bias. Critical thinking predicts a wide range of life events. In a series of studies conducted in the US and abroad, Heather Butler and her colleagues have found that critical thinkers experience fewer bad things in life. They asked people to complete an inventory of life events and take a critical thinking test called the Halpern Critical Thinking Assessment. It measures components of critical thinking skills, including verbal reasoning, argument analysis, hypothesis testing, probability and uncertainty, decision-making, and problem-solving. The inventory of negative life events captures different domains of life, such as academic, for example, I forgot an exam, health, such as I contracted a sexually transmitted infection because I did not use a condom, legal, I was arrested for driving under the influence, interpersonal, I cheated on my romantic partner, financial, I have over $5,000 of credit card debt, and so on. Repeatedly, the researchers found that critical thinkers experience fewer negative life events. This is an important finding because there is plenty of evidence that critical thinking can be taught and improved. So, is it better to be a critical thinker or to be intelligent? Butler's latest research pitted critical thinking and intelligence against each other to see which was associated with fewer negative life events. People who were strong on either intelligence or critical thinking experienced fewer negative events, but critical thinkers did even better. Intelligence and improving intelligence are hot topics that receive a lot of attention. It's time for critical thinking to receive a little more of that attention. Keith E. Stanovich wrote an entire book called What Intelligence Tests Miss. Reasoning and rationality, rather than spatial skills and math ability, are generally what we mean when we say a person is smart. Improving intelligence is difficult. Critical thinking, though, can improve with training, and the benefits have been shown to persist over time. Anyone can improve their critical thinking skills, and doing so, we can say with certainty, is a smart thing to do.